Hello, my name is Carlos and I'm a VFX supervisor at El Ranchito. I've been working on the VFX industry for 22 years now, and I have focused my career on creatures and characters, and especially how to make them feel alive, how to make them feel believable, and that's exactly what we're going to do in this course. We will use the creature that you see right now on screen, and using different techniques like deformations and muscle simulations and skin simulation, we will try to get to that next level of realism so it feels much more alive and it feels believable. So to do that, we will use Houdini on this course. So this first week, we will learn how to move around Houdini, how the software works, what the nodes are. This is not the same box that this one, so they are two different nodes and why this is happening. We will do a little bit of Bex also, which is the programming language here on Houdini. So we can create this. This is just like a morph, like a blend shape between two objects using painted attributes, painted mask. And we will end up having a shot like that, where you can see we have a character walking and deforming the terrain. That is a deformation. There's no simulation here going on. It's just deformation with some tricks that we will use later on our setups to create really nice character effects and to make that creature feel much more alive. So that's that. Let's just begin. Okay, let's start with this Intro to Houdini. And let's say you're an artist coming from Maya, Blender, or wherever, and you don't really know the basic things in Houdini. I know it's going to be scary at the beginning. Just keep in mind, this is software made by engineers, really. They are not that artist-friendly people, but you can do amazing stuff with this software. And also you can change it a little bit to make it more artist-friendly. So let's begin. As you can see, this is a viewport. This is default viewport. You can hit Alt and navigate exactly the same as Maya, but the space bar is really the navigation tool. You can see it right here where I can I think it's this one. Yeah. So, no, this is escape. Yeah, it's exactly the same, but let's say I want to create something here to move. So I have here my parameters and here my object context. We will be talking about context a lot, and don't be scared. Don't worry about that. Let's just create a sphere. Let's start with the basic things. And okay, so I can move around exactly as in Maya. I can hit S. So this tool right here, this is the select. So I can select. This one is exactly the same to do that than to do that. I'm selecting the node. Everything are nodes in Houdini. And I can hit the space bar and F. So I do the frame, and spacebar A will be the frame all, everything just as Maya, and you have it something around here, I guess. Don't remember where you have it, but yeah, home and frame all, you can see frame selected, whatever. Okay, so we have that, and to move this, Houdini is also a QWERTY software, but it goes the other way around. So the T is for translate. So you can see I can translate my object. The R is for rotation. The E is for scale. And the W goes to the wireframe mode. A little bit different, but you can see. Okay, so the S is for selection, as I said, and the space is for moving around. There's a thing with the moving around, with the rotation, that it will happen to you for sure the first time. Let's just create a grid and put a scale of 100, something like that. So by default, this comes like that, set pivot on the tumble. So if I start rotating, clicking on my sphere, this is going to behave as Maya, but if I click here, this will rotate from the point I'm clicking. As you can see, the pivot is changing. So this is not Maya. It's pretty useful when you get used to it, but maybe you don't want that. You can change it just right here, hit in the space and keep the pivot. So now I can just frame the sphere and I don't care where I'm clicking, that the pivot of the tumble of the rotation the orbit one is always at the same place, or it's behaving just like in Maya. You know, I'm moving it as I'm panning and dolly out or dolly in. So just keep in mind that when you're starting to work and trying to move things around, because this is how it works. Okay, so as you said, I can change the uniform scale here, but I can also hit the E and start scaling. But this is doing a scale from X, Y, and Z, not a uniform one. It's a uniform because it's the same exact thing, but I can start just playing with the X. And as you can see, I'm scaling it just with the X. And you have a really nice thing here. Let's just grab the sphere and go to the transform node, and you can hit T and move it around, or I can just hit here or the plane. This is exactly as Maya, but you can middle click here and you will see that you have some numbers. So if I just go up and down, holding the middle mouse, I can start moving it like this, or I can move it like that. You know, this is pretty useful, and it works. It really works when you get used to it. So just keep in mind you can change your objects like that. Saying that, well, with that said, I can tell you that Houdini is not really an amazing artist-friendly software to move things around. It's not made like that. They are changing it. They are creating nodes for doing layout and things like that. But it's not as fast if you already are fast moving objects and placing objects in Houdini, in Maya, or in Unreal or Blender or whatever. I think it's better to do it there and just bring it up, bring everything from there, and start doing other stuff here. But you can, and at the end of the day, it's exactly the same. It's just it's not as user friendly as the other ones. Okay, so you also have some tools here with the X and C and V tools. You know, the X can do like a grid snap, something like that. You can see the points on the grid. So, and I can do it by primitive, and I can do it by point maybe, and it tries to keep some points there. So you have this functionality with the snap, also with X. With C, you have the context menu. Right now we're on the build menu. You can change that to create another layout. Also here, you can create a lot of stuff here for that. So let's say I want to, I don't know, maybe I want to groom something. So if I just change that to groom and hit the C, you can see now I have the sculpt tool for grooming, or the brushes from the grooming tools and everything. So this one will change my C menu, really. And the B is just for select. V is selection option. I don't use that. Okay. So we were in, I don't remember which one it was called, main, I guess. Yeah, the standard main. And here you can do a lot of things and start a lot of stuff. But I don't work that much in the viewport for these things, really. And this one is to change the layout. So right now we have this layout with the shelves up here and our scene view. We have our parameter editor and our object and context here. And you can change that. Let's say I want to do grooming again. So it will change a little bit. So you can see we don't have as much tabs here. We don't have all the other shelves, just the important for grooming. And it changed that to hair automatically. So that's that. Let's change it again to build. You can see we have a lot of things here already. So let's say I want the animation editor. This is a graph editor, just like in Maya, where you can just create some animation here. So I can hit that to key, just like the S button in Maya, to key everything. You will see it, and you can change it to create auto key for changes and everything. So at keyframes is the K, and so I can hit K and it's exactly the same thing. I prefer to use the auto key always, but so let's just key. You can also key it with right here, and you will see here there's a keyframe, set keyframe, Alt left mouse button, so I can hit Alt and I'm storing a key on the translate channel, and I can do that, and I'm just keying the white channel. So let's just, you have down here your graph, so let's just put a keyframe right there because I have the auto key is already done. If not, just Alt and click and I have the key, and you can see right here our PDF, our graph editor. We can do that. We can change the tangents and wherever. You can do almost everything as in Maya or Blender or any CG package, really. And when I hit play, you will see this is going really crazy. This is because by default, it's not doing any real time. So as you can see, we are at 120 frames per second. If you don't see that, which is the default, I guess, you can hit the D here in the viewport, and you will have the display options on the viewport. So we have a lot of things to change. We can change, as I said, the draw, the time, the frame per second, and we can do, I don't know, maybe add some anti-aliasing. This is really useful when you're grooming for hair. And you can create another background. So do the dark background, gray, dark gray, you can do whatever you want. Here, there's a lot of options here for the viewport. And also you can see here, there's some buttons right there. So I can do the real-time toggle, and you will see that this is only going to 25 frames per second, which is my frame per second right now. If I open this, you will see at first one, the options here. So this is the global animation options. We can the start and frame end. So let's put it to 24 maybe. So this is just 24. Let's apply it, and now everything is 24. So you can change also, obviously you can change the numbers here. So and do it like that, and you can play with that to get the frame range you want. You could also create that, and you will see decimals on your keys, or your frames really. And this is looping, zigzag, P1s, everything pretty straightforward, pretty just like any other package really. So this is how it looks at real time. That's great. So now we can move, we can do some animation, and you will see that here I have my geometry and I have my parameters. So I have a transform, I have my render options. This is for Mantra, and I don't know if they work for Karma as well, but this is like all render options. I have Arnold installed, so I have an Arnold tab. This is exactly the same as the Arnold tab from Maya with the subdivision and displacement and medium pixel width for the shape. They are curves, whatever, and you have a MISC to create another wireframe color as an example. So now this has another color, and I can just go here and create another color for the ground, and you have these kind of viewport things. So you can also disable the selection in the viewport. So now if I hit S, I cannot select that one. I can just select the sphere. You can see nothing happens. Now it's sphere. I just turn that on again. I can select them both, and you can see they are yellow right here. So we have both of them. Okay, so we can select, we can move around a little bit. And how about selecting components? So let's say I want to select here something in the component world, right? I can select the vertices or maybe the faces, or well, I cannot do that here right now, because as you can see, I have no options here. I have options to do a lasso selection. I have options to do paint selection. I can paint that and select that. I can create this, which I think this is the laser selection, which it doesn't go through the object, as you can see right now. If I do that around here, it goes through the object. It selects both objects. If I just hit this one, it doesn't go through the object. And you can also select visibility. So I can just do that. And now I'm not selecting the background, the grid, really. So lots of things to do selections here. And also, if you want to change the view right here, as you know already, with W, you get the wireframe. With Shift W, you hide the wireframe unshaded. Shift W, and you can also change it right there. So you have a wireframe bounding box and shaded bounding box, wireframe ghost, which is the default, which is ghosting the back face lines, hidden line, just to get that hidden line ghost. There's a lot of things. Markup shaded, flat shaded with wireframe, and smooth shaded with wireframe. So W will change between this one and this one. And with Shift W, you will change from this one to this one. Okay, so you have a lot of things up here. Don't worry that much right now. I will continue with these ones. This is the render view to create some renders. We won't be rendering right now. This is the composite view. Houdini has a compositing network also. I just changed that one, and you will see some change up here. I will explain that in a minute. And same thing with that, with the motion, it will change to channel. And now this is not changing, but it's really this one. We will see what all that is. And the geometry spreadsheet, let's just go back to the object context and see the geometry spreadsheet. And you will see this is the number of the point, really, because I'm working here on points. You can work on points, on vertex, on primitives, objects. On detail is like on object level. And this is the number of my points. So my point 0 is in a position minus 2.1 in X, 0.5 in Y, and minus 5.6 in Z. So this is the position of each one of the vertices of the points. They are not exactly the same, we'll explain that, but of every one of these points. So let's just create a cube and let's see how this cube is right there. And you will see we have 8. It starts with a 0, that's why we have 7, but they are like 8 points. It's what a cube have. And because it's in the 0, 0, 0, in the origin of the scene, you can see it has this point right there. So we can, let me just, you can do that. So it's not selectable anymore. It's the same thing that changing this, just right here. And you can change that. And the blue one is visibility, really. Okay, so I have no visibility right there. And so selection, visibility, and you can see this eye right there. And this is information for us. So this is pretty useful. And you can just hit middle mouse and this will appear and disappear as you hold it. Okay, so let's try and see this P attribute. We cannot see it right here, but I will just do something right there. Okay, I think I'm going to stop the video right here. We have a basic introduction on the navigation and everything, and we will start working here, which is 90% of your work will happen just around here. See you in the next one. Okay, so let's continue. And maybe if you come from Maya, you will say, okay, this is a box, but I cannot change subdivisions or anything here. I'm just saying the transform. Well, it's exactly the same thing in Maya. In Maya, you can, in the transform, you can only change that because this is like a group that has something inside. And as you can see, I have a box, I have a sphere, and let's put it like that. I have a grid, I can have whatever I want. And this node is exactly the same. It's a geometry node. You can just look at that, or maybe just hit the Y and you can see this is geometry object, geo. This is the node. And they are all geometry nodes. So they are all like transforms in Maya. But if you want to change something, you have to go inside them. So let's double click one of them. And now we are inside it. And now we can change the subdivisions, and we can change anything we want, really. So the radius, it's not the same, changing the radius as scaling, because now we are scaling the shape, not the transform. It's exactly the same in Maya. Okay, so you will notice that this has changed. Now we are in the geometry context. And this is pretty important because this is the object's context. And as you can see, we have here a lot of context. We have channels, which is for animation. We have the image, this is for compositing. This is material to create materials. Objects, which is the one in we are right now. This is the out, which is for rendering. This is the shop, which is almost the same as the material, but the old one. This is the stage where we can create USD and Solaris stuff. This will come later. And the task, which is COPS, where you can create automatic things and procedural things to be really processed all at once. So right, you can see here our contents, all that we have. And if you want, you can hit here that button and you will see our tree. So we have nothing in the channels or material or whatever. And we have something in the box. And all of them has, this is kind of the tree that you can see in the outliner in Maya. It's exactly the same. It's more or less the same, but that doesn't work like that. So I don't really like doing that, but you can do it if you want. You can try and hit here. So this is going to show you with another type of view. This is not that working, but you can create parenting and constraints here. We will not see that really. And if we continue, we can see the colors right there, and we can see shapes. So we can change the shape really of anything we want. So now this is like that. Also the color for sure. So now this has this blue color or whatever. Okay. And we also have backdrops, which are really, really great. So let's say this is our environment. So let's just create a backdrop here and just type environment. We can create a lot of stuff right there. Sticky notes. As you may know, this is a sticky note. If you know something about Nuke, it also has sticky notes. So this is my environment, whatever. Obviously, you can change a lot of things here, and double clicking that will minimize that. And also you can change the font size, do it larger, whatever you want. That's really great. You can move that out in. It's already creating, as you can see, within the nodes. Well, you cannot see it right there, but maybe I can just go outside. You will see this kind of line going on. So it tries to create great lines, so everything is really well layout. And you can put some images there, background image for this, not really useful, but you can, and you can create groups of everything. So I can just grab all of them and create a subnetwork, it's called, which is really a group, and you will see that. Also, you can find node. So let's say I want to find the sphere, select and close, and now this is going like that. Sometimes you have huge trees and a lot of nodes and you don't know where they are, so it's pretty easy to do this again and hit sphere and select and close, and you're there. If you have some more nodes, you will see here, well, you will see it in a minute, but maybe we can do that. Not in this one, I guess. But yeah, it's pretty useful. You have here all the calories and stuff that you can have. So creating new nodes, I just hit tab and I can create like a sphere or whatever. I don't know even where they are anymore. Here you can see I can create all that. But the usual workflow is just to create something that you know. So maybe we want to create a camera. So I just hit camera, hit enter, and now I have a camera. And you will see that the camera has a transform, has a view and sampling, which is a little bit different because this is a camera. This is not a geometry. You can see that these things have changed from here to here because this is a camera. So this is a transform also. I can go inside and this is my shape, really, and it's geometry. But the camera node is a geometry node, but with something special because it's a camera, right? So we need to have the resolution, the focus length, and whatever you want. So if you want to see things from this camera, let's just go here and I can select to create a new camera or the camera one that I already have. So this is what the camera one is looking at. And if I move right now, nothing works. I break it. What's happening? What's really happening is the camera is here and you cannot move cameras like that by default. You have to go here to camera and hit this lock camera into view button. And now I'm really moving the camera around from the camera perspective. So now you can see I can add like 100mm focal length, something like that. And now I can just hit this button and you have it. That's great. That's amazing. Okay, so obviously I can just grab the camera and move around with the usual keys and everything is the same. Don't worry about that, it's exactly the same. And we will focus on this right now. So let's try and just grab this sphere and go inside. So as I said, this is the shape, and the shape has exactly the same as Maya. But in Maya, I've got something like that, and maybe I want to add a subdivide node, which is exactly the same in Maya. Let's just grab Maya a little bit just to understand that, because this is exactly the same. Let's just do that. I will delete the history. Oh, sorry. I will freeze the transformations. No, not yet. So in my shape, you can see I have this subdivision and I can put it 40 something. But if I look at the node editor, you will see that we have nodes really. And this is my polysphere, which is where I can change the radius and subdivision. So let's say I want to subdivide that. What it really does, it's another node called polysmooth, and you can see it's one subdivision here. Let's put it like that. So we had 40 and 40 and one subdivision. So let's jump to Houdini again, and you will see the same thing. So this is the sphere. Here it's called polysphere. Here it's called sphere, and the subdivide node, which is called polysmooth face here, and this is subdivide. Let's just add that, and you will see we have exactly the same. With one subdivision, we can do two subdivisions. Exactly here, we can do two subdivisions, and they are exactly the same. Nice thing about that is that in Houdini, you don't have to delete that. This is the important part. You keep all the history always. So in Maya, you used to grab that and delete history. Delete history. And I can now go back. Here, I can always go back and say, I don't want a sphere. Maybe I just want a cube to be subdivided. So you have a cube subdivided. Everything's working. Everything is amazingly nice. So as you can see in Houdini, you have inputs and outputs for your nodes. They go from up to down, and you can create crazy, crazy stuff here. But I wanted to talk about the context. So this is the geometry context. So this is everything I can do with the shape, deforming it and add more subdivisions and whatever you want to do is going to be here. And this is called SOPs, surface operators. So you will hear a lot of these because this is called chops, this is called cops, and this is called ROPs. And yeah, so render operator. So you have all these crazy names that these people just created, and I will not talk in this language because I think it's confusing. I will just say like the object context or the geometry context here, and we can create another thing. Maybe we can create a ROP network, which is a render operator. So the render context. And just keep in mind that we have here a render context. And you can see if I go here in the out, this is outputs, the output context, the render context. And if I go back here and I just double click this one, this is exactly the same, but this is my ROP network. This is my render context. This one is the one that comes from the file, but I can create all of that by my own if I want. So this will be the material network. and I can create my own material network. And just look at the icon is exactly the same. And this is my material network, but this is mine. This is a custom one. So you can create networks inside networks, and you can be really crazy about that. But I prefer to do it like that because it's a little bit easier to understand. Also, because I just imagine that my grid is my environment and my sphere is, I don't know, maybe this is let's put it like that. And this is a prop. Oops. Some imagination here. Let's put props. And let's say my box is a character. Let's move it out. And this is a character. Okay. So you can imagine that I can have a lot of things going on here, and it can get crazy really, really fast. So it's a nice idea to have it everything in a way. So let's just grab this material network right here, and I will create this character material network, or in fact, with the characters, it can be just one for the box and one for another character that I have. And I will duplicate that. You can duplicate nodes. You know, Maya, you cannot do Control C, Control V. It's really forbidden because it's going to be crazy and do crazy stuff. So I can just grab this node and create Control C, Control V, and it has pasted another. Anyway, you cannot do that with the material network. Sorry about that. But the best way to do that is just hit Alt and drag. So I have another material network. So this will be my prop material network. Oh, you don't have to do the underscores. You can just hit space, and because Houdini is a really, really smart software, it will do underscores. Nothing will have spaces in a name, so don't worry about that. And Alt and drag again, and now I have here my environment material network. Okay. And for sure, we can just color code that. So my environment will be always green, my props will be always blue, and my characters will be always, I don't know, red or something. Okay. So now you know everything. So let's just do that. And I can create another one for cameras if I have multiple cameras or something like that. So these will be my cameras. Let's say cameras. And my cameras maybe, I don't know, another color. Let's put it like that. And these will be my outputs, my render outputs. And let's put some color here also, something like that. And we have everything we need. So having that in mind, I have everything in color coded, and you can see it from really far away. And it's going to be easier to work like that. I just recommend to do something like that to be sure that you're getting everything in place, and you have some order here. We can even add more space right there. Okay, so again, if I go inside here and let's create an Arnold node to render Arnold, this node is called out Arnold 1. Okay, let's go out here and let's just open this render context and create an Arnold node. So this Arnold node is called object slash prop network slash Arnold 1. You can see my camera is called object camera 1. So everything in Houdini is connected that way. You have always a description of your node, what this node is. You can see right here, this is called object prop network 1 Arnold 1. If I change the name and I say my renders, when I just go inside, you can see that my object now is called object slash my renders slash Arnold 1. The fastest thing I can imagine to understand that is that these are just folders, really. So I can have my main folder here, and in my main folder, I can put some file called Arnold1, but I can go to my object folder, my default object folder, and create a folder for render things, for render networks. And I can go inside, and now I have a file called Arnold1 in my object folder, my renders folder, and this is the file. So this is kind of like folders in Houdini. They are folders, really, they are just nodes and how and where you put them, but you can understand that. So I don't have any, let's just use this one to create also lights. I will create an Arnold light, and I will just create a skydome. So we have this skydome right there. And let's try and do a render with that. So I can go to the render view, and you will see that my render view will let me choose. Which Arnold do you want to use? Because I have two nodes for rendering. I have really two renderers right now. Your object my renders Arnold or the out Arnold, because I can choose between this one and this one. Okay, let's just do something here to understand that. So I will go to my camera samples and go to 0 in this one. And in my render, I will go to, I don't know, maybe 5 or something just to get some idea. You will see the change right there. Okay, so I can choose between them, and I also can choose between the cameras. I have some scene views and the raw camera, which is the one that is defined right here. So you can see this is the camera, object camera 1. So, well, it's exactly the same, but put that, and let's hit render and see what happens. You will see by default, this is my camera view, that's great, but there's no materials here, so I don't know if I can see the difference right there, but let's change it and maybe we'll see something. Not that much, it's much, much faster. Well, you can see here the anti-aliasing not working because that was at 0, and if I change that one, this is much more anti-aliased. Okay, so that's great. And Arnold by default doesn't have any materials, so let's just create some materials here. And let's just dive into the material network here, and I will create an Arnold material. This is my Arnold material, but I have to go inside that. So let's just say I want a gray material or something, gray material, and I will go inside and I will create a standard surface. You will see that this is exactly the same. This is the same, exactly the same material from Arnold in Maya. So Arnold is everywhere the same. That's a great thing about that. So let's just put some gray value around here and just connect the shader with the shader. And that's pretty much it. Okay. And I changed that name because this is the one that I'm going to use. So let's hit Control C on this to copy it. And let's go to my box and say, okay, what material do you want to use? I can go here and choose materials. We don't have any material in the default material context, but we have some materials here. Oh, we don't have some materials. We just have one material in the channel, in the character material network that we created, and this is the great material. So I can do that. And as you can see, it's just a relationship between what material do I put here and where it is. So this is in object, chmagnet, and gray material. This is the one. I will delete that, and I will just do a Control V. You remember the Control C. So it's exactly the same. When you do Control C in one node, you're copying the path to the node. So you can do that really easily. So let's just write this gray material, Control C again, and open the prop material network. And I will Control V it. As you can see, it has the same name, but because the names in Houdini are full path names always, they are not relative path. You can create relative path, we'll see how, but they are full path. So I can just have the same gray material and call it the same, because I can go up here and say, which material do you want? In this case, I want the prop gray material. They are the same, but they are on another place. So let's say prop material, gray material. Let's just grab this gray material and change into a red material. So now I can change that name and say red material. And look at that, the relationship, it still exists. And it just changed automatically to red material. It's just a name. But the relationship exists to a node that it's this node. And this node internally for Houdini has a UD and an ID. So this is the ID working and just changing the name. We see the names and we work with the names, but internally it has some ID. So it can do this kind of relationships. Let's create here another material. This is going to be floor material or whatever. And let's change it to another color, maybe that, something like that. And we will don't use the specular, whatever. So now I can just go to the grid and see which material I want. I want the environment material network floor material. So I can create networks, I can create things inside networks, and networks inside networks, really. And you will see right now that when I render that from my out Arnold, this is pretty fast, but it looks pretty rough because it has, um, samples for the camera rays. You can just go up here and close, and you can close it with this sidebar really and open just clicking. And I can just do home view, zoom, wherever, change this. This is not going to look that much, but you can see AOVs right there, and you can just keep the eye to see what's happening here, the size and whatever. And also here, you can open that one to change the exposure or a lot of stuff. And if you have aces, as I do with OpenColor.io, you can change that to whatever you need for your thing. So it's mostly the same. It's not that really difficult to understand that you have a lot of options here, but this is not a rendering tutorial. So this is just to understand. I thought it's pretty easy to understand that you can create materials and you can see right here, it's much, much better. And again, this is the same thing as Maya, so I can grab here and go to my Arnold tab and create some subdivision and subdivide a couple of times, maybe 3 times this sphere. So when I hit render, this will be subdivided. Exactly the same thing with displacement. Everything is exactly the same in Arnold, but I have a really, really great layout and scene right now where I can do a lot of stuff. So I will delete right now the output, this one. I don't use, I think I never used that, the original ones, like the default ones. I always create my own, and it's easier to have all the environment materials there, all the characters for this character here, and maybe we'll have another character, which is another thing, and I have something like that. So this is my man, I don't know, man character. This is my woman character, and this will be like woman character, material network, and all the materials for the woman will be there, and just so on and so forth. Just keep in mind that I just changed that. I just duplicate everything with the alt and dragging, but as you can see, this man has a connection with this material network 1. So it not only copied the nodes, but it copied the relationship between them. So now I have a new material that I can change right here. And let's say I don't want that gray anymore. I want it, I don't know, purple, whatever. So my man will be purple, and let's just change that. And this will be man mapping network, and this will be the woman network. And as you can see, everything stays with the same relationship. Let's just grab the man and put it around there, maybe. No. And let's just create a render just to see how this is working. Yeah, that's great. This is working. Everything is working fine. Let's go to the camera. Maybe I can just move the camera around and create a better view for that, And that's pretty much how I think you can start understand how the networks and the objects in Houdini works. So, quick tip here: you can create this and change the name and say, I guess that you already think about that, but let's just say something like that, and let's call it the fast render, and then I will call that final render, whatever, or final render options. And in this one, I will add a lot of subsamples or whatever, and you can change a lot of things and add the motion blur and put some keys there, whatever you want to do here. So now I have two nodes, so I can start working on just and do the fast render here, and this is going to be pretty fast. Okay, that's great. And my final render, let's see how that looks. And this is for final rendering to the farm or whatever, for final rendering at home. But it's going to be much cleaner, and we're doing like 10 camera samples. Okay, so that's it for the beginning, and see you in the next one. Okay, so now we're going to do something more character-centric. At the end of the day, this is a character course. And let me just say that I almost never use the shell, because it creates a lot of stuff that I don't want, and I don't know what it's doing really. So it's easier to do it yourself, but just let's say I want a tube right there. I can put it like that. It comes with a nice gizmo to move it or do whatever. This is the one. Which is called enter, which is the enter, really. It's not called enter, it's the enter button that just triggers it. And it's wherever you're in selected, whatever you have selected, it's the tool that you have. So I can hit T and just translate it, or E, R and just rotate it, but I can just hit enter and it goes back to this gizmo where you can do these kind of things. Because when you create a tube, this is the main tool that you have. But if you look at that, this is just a geometry called tube object 1, and this is a tube. This is a cylinder, really. This is the shape of the tube. Okay, so let's say I just hit escape and go out of this tool. I can come back to the tool if I want. And let's say I want to do, I don't know, maybe a bend. So let's set bend, and you can read down here, select start and end of deformation, and presenter to the form multi-selected geometry. So I will just select this and enter, and you can see that it grabs a tube and creates a bend node inside this. So now I can bend that. It's great. Thing about proceduralism is exactly that. So I said, oh, come on, I just created a deform bend node operator, or call it whatever it is, but it's really just the bend node. But it doesn't really work really nicely because I don't have enough subdivisions. I can go up here and create a lot of subdivisions there, and maybe some more subdivisions there, and whatever I want, and I can just go back, and the bend now is working pretty nicely. So this is procedural. I can change the input, and the output is exactly the same. It's doing the same thing to the new input. Okay, so you can do that. This is nice. You can do it if you want. Let's just hide this one. But I prefer to just create things. So let's just create a geometry node. Go inside, we're in the geometry context, and let's add a tube. Here we have a tube, it's exactly the same. And now I can create a bend node. And as you can see, the bend node requires two inputs, a geometry to bend and a rest geometry we want. So let's just create that. And you will see if I hit enter, I have the same tools, but they are not on the same place. So the nice thing that this did was to set the capture, in this case, the capture on its place. But I can just set the capture region and click on the tube and do exactly the same thing. And now I have my bend. It's exactly the same. It just hit that button. And I don't like that because sometimes it creates a lot of stuff that I don't need, and um, some other context and things to work with, and it gets pretty confusing and pretty complicated with the time. So I prefer to create everything by hand and not use the shelves. So we won't be using the shelves for anything. So let's try to create something here that more or less works. So let's just delete that one. Just hit delete on the keyboard and delete the um, node, and let's try to maybe select something. I will create some mem, and let's say I want to select these. As you can see, if I hit S, now I have a lot of options, more options, not a lot. All those were already there, but these are new options. So if I hit here, this is a detail attribute. Don't look at that match. But these, as you can see, are primitive, so I can select that. Some primitives. Also, I can again select with the lasso tool, with the laser tool, so it's not selecting back faces. With the paint is selecting the back faces, but I can just do paint with the visible, and I will just select these ones. Pretty great. I can just with the wheel on the mouse, I can just make better selection. And I can also select edges. Sure, these are edges, and I can select points. These are points. Okay, so if I have this selection, I can just hit E and move it, and it creates an edit node to edit my geometry. And it also created a group with my selection, and I can move these points. So what this is not like a modeling software, really. You cannot do a lot of stuff. You can do a lot of procedural modeling, and we will do a little bit of that. But as you can imagine, moving that around and trying to play with that, it will create a lot of nodes. So like the history in Maya when you start moving things. So let's say I will hit S and select all that, maybe with the lasso tool, and I will select only these points, and I will just move them around. So it's the same edit node right now. It doesn't create another one. Has some history here, but not that much. So it's pretty hard to do that. And you can do that, as I said, just like that or manually. So maybe I want to create another edit node. So, this is called edit one, and this is called edit. This is a sub operator, geometry operator, but it's called edit. So let's create another one by hand. Let's do edit two. And this is doing nothing. What I can do is I can create a group. We will be talking a lot about groups, and I can just click here and I can create a face group, I can create an edge group, I can create a point group. Let's just go with the point group and select all those and hit enter. So now I have my point group and I can move them around. As you can see, now I have my two edits. So you have your history here. You have cube, you have this edit, and you have this second edit, and you can blend with them for sure. So let's say I want to create, I don't know, just character, right? I can create a blend shape. Oh, by the way, it started to look pretty messy with the lines right there. So, and just hit Shift S, and it will create these curved lines, which are really nice. And you can Alt click in one line and create this kind of thing. So I can just create another right there. You can hit Y in your keyboard and you will see these scissors to do that. And you can also grab these and just shake it, and it will also disconnect them. And there's a lot of hotkeys to connect and do crazy stuff. You can just look for them. It's not, you will end up just using the Y, and that's pretty much it. Okay, so let's say I want to create, let's just put them there, and let's create a null. This is a node that doesn't do anything, just to have something here. because it's easier to see, right? And this is without deformation, this is with the deformation. So maybe we can create a blend shape. There's let's try. There is a node called blend shapes, and this node requires the source. So this is the source, and here are the blend source. So let's just do something like that. This is one, this is two, and let's look at that. So now you will see we have the first one. Let's add the other one. So we have the other one going on. So as you can see, this is not working right now. It's doing like two blend shapes. Let's clear and update it from the channels. So if you do that, as you can see, we have the names. So let's change the names. This will be like a belly, and this will be like a neck. Let's imagine this is the character. And again, clear, update channels, and you will see that now this is my belly, and now this is that. And because this has both of them, this is working like that. But because this is procedural, I can just grab this one and put it right there. So now I have just this deformation, and here I have this deformation. So now we can blend between them as we want. So this is like a stupid example, but it's just for you to understand how proceduralism work really in Houdini. Is you can change things, you can separate things. This is storing just the edit that I did for the belly. This is storing the neck one because I did a couple of them here, and you don't have the numbers, but you could if you just do one edit, you will have just the numbers for the belly, and these are the numbers for the neck. And you can see that I can blend them together in a blend shape, really. So let's say this is working nicely, but maybe I want to create some subdivision here. So at the subdivide node, we have already used that. That's great. This is working perfect. And obviously my blend shapes are still working. And maybe let's say this is too much. I don't want this to be that much. So maybe I can just create a soften, or smooth, and this will smooth my geometry a little bit. You can see we can do more strength, less strength. I think this is working nicely, and the smooth is working on the P attribute. The P attribute is the position of every single point. So it's trying to smooth that numbers, that position, all those numbers that we have, with this one being the point number, whatever. Well, I will show you a little bit, and I will show you that earlier on the course because it's pretty important to start being less scary about a couple of things. One of them are attributes, and the other one is vex. Vex is the programming language in Houdini. It's pretty easy to understand, but let's try. So right now I have this P attribute. Again, with the Y, with the I, sorry, I have everything here. So this geometry has 408 points, 384 faces, and 1,536 vertices. Why this number is not that? Because Houdini does one thing, and it's pretty awesome. Really, it differentiates between points and vertices. So a vertex has a normal and has 4 edges in this case attached to them. That's like 4 times this number almost. This is exactly what it's doing with vertices. And primitives and polygons are exactly the same in this case, because this is a polygon and they are the faces. But the points are just this point. It doesn't matter to what it is attached. So you will be working fairly almost ever, always with points. So let's see. We have just one attribute, and it's a point attribute, and it's called P. It's a 3 float, so it's 3 numbers, and it's a position. Let's hit this and see what happens. Whoa, this is starting to get complicated, right? Don't be scared. Don't worry about that. So right now we can see, maybe you cannot see that, but I can just hit D, I guess, or maybe here. Yeah. So this is the position X, Y, and Z of every one of them. And I can see that because I just hit here. But if you don't want to see anything, this is the visualization for the attributes. So you can just click it and so to toggle it, and you can right click and see what I'm seeing. And what I'm seeing is the P in this case. So you can also activate and disactivate here because you can have like a huge list here of attributes that you want to see. And also you can change the way it's drawn. So this is a marker. It can be a color. We will be using that a lot. And right now it's text. So we can change the font size and make it bigger so we can see better the numbers. We can change maybe the color so you can see it better. So now my P attribute is looking like that. I know this looks like a mathematician thing or something, but just follow a little bit and you will understand it pretty quickly. So this P is the position of each one of the points. As you can see, we have one P for each point, and this is the position in the 3D space, X, Y, and Z. That's this attribute that I'm smoothing. You can see when I smooth or unsmooth this, it's changing because the P attribute is that. And if you go to the geometry spreadsheet, you will see that my point number 0 has this P value. Okay, so this number that I have seen here, it's called PTNum in Houdini. And we can play with it and we can also try to visualize it. So let's just do something like that and let's create an attribute. So you can create an attribute, just attribute create like that. That's pretty much it. I will put it here. And by the way, I just forget to show you that one. As you remember, this is for visualization, this is for selection, and that's it. But now we have 4 of them. So the first one is to bypass things. So let me just look at that and hit, this is for visualization, as you know, and the first one is for bypassing. So if I bypass the smooth is not working at all. So this is bypassing. This is for freeze. It's a little bit complicated to understand that. It's locking what happens before this node. Don't use that often. So, and this is for template. So I can template this. You cannot see that, but maybe you can template that one and you will see this template in a wireframe. So I'm doing some template on these other objects that I have here, just to compare them. Okay. So, and by the way, this is also QWERTY. So I can just hit Q and select that one and it will bypass it. I can select W and it will try to template. I can hit R and nothing, E, nothing happens, and the R button is going to hit to show it. So I can just R and click, and I'm seeing them instead of just trying to find that. If you're looking at a huge tree, it's much better to do R like that and look at that than to try to hit the blue button from here. You can do it, but it's not that easy. Okay, so I will create this attribute, and this attribute will be called new PTNum, just to call it. And you have a lot of options here. This is a point attribute, yeah, we'll be doing in points. This is a float attribute, but it's not really a float attribute because a float attribute goes from 0 to 1. So this should be like a vector attribute. And now you will see we have a vector here and a position here, which is 3 floats. It's also a vector. A vector is 3 floats, so 3 numbers with decimals, three decimal numbers, which are called floats. And I can just try to show it. And you will see right here that these, and I will just do the same with text. And I have here my attribute, which is 0, 0, 0. Let's do that. Right now, it doesn't have any value because I have a default value of 0. If I put here 1, by the default, no, if I put here 1, sorry, and the value is 1. Okay. So I can just do something like let's use the position that we already have. So this will be at p point x. Oh, so this is exactly the same as the p value in the x attribute. That's how you write in Vex the p attribute and the first of the three values it has, x. I think you can also do r, and it's exactly the same. So x, y, z is a vector, three float values. RGB is also a vector. So let's just put right here p dot y, for an example, and p dot t, and go so on and so forth. So you can change that. Also, when you have some expression, you can click it and see the number. Right now, there are a lot of numbers, so it doesn't reflect here, but it reflects here because I'm doing that for every one of the points. So for each point, just grab its p and put it as a value of this new ptnum add. Okay, but this was a ptnum, so let's just delete this channel and create a integer, because the ptnum is an integer. The number of this point is, as you can see here, is 0, 1, 2, 3, 4. It doesn't have any decimal, so it's an integer. So let's try and use as a value ptnum. And here we have ptnum is a variable from Houdini, just as p, and we will be using them a lot, so you will learn a lot of them. So you can change that for anything you want. So let's just do $f, and these $sign are global variables, and at and something are like local variables. We'll talk about that in a minute, but as you can see right now, this is $f. So my new attribute called new ptnum is the frame. I can change the frame, and you will see it will change the attribute. They are just attributes. They are just information. Let's keep it with the at ptnum. And as you can see, if I hit $frame, I can try and create something, and you have a list of all the variables that are global, that are from the scene. So a frame is from the scene. Every geometry in the scene, everything in the scene is has the same frame, right? Is a scene thing. And with the at, there's nothing here, but I can start writing, and I know ptnum is the point number. So this is local. This is for only this object, not for all the scene. So now I can see my objects right there. I can see my 0 right there. So this point is this point. And the point, if I just click on the P also, let's see if I can go inside, and you can see that 0 has 0 0.7, 0 0.7, whatever, and you can see that it's exactly the same thing. So my point 0 has these are my x, y, z vector values. Okay, so you can do a lot of stuff with that, and this is the most basic Vex thing that you can have. But again, we can do that in a lot of ways. Let's open these and just not show these attributes. And now we can do all of that with just one node. Let's add an attribute wrangle, where you can just write Vex code directly. So I had this name for my new ptnum attribute, and this is at new ptnum attribute, really. So let's do the same thing here. So I'm creating a ptnum attribute, which is exactly the same as my ptnum. And in Vex, you have to, and everything with a semicolon. Yeah, semicolon right there. And right here, we have another float number. And this is a float. As you can see, this is an integer, because by default, Vex always think that you're doing a float. But you can just put I. So this is saying integer attribute called new ptnum is equal to attribute ptnum, which is already an integer. So now you will see this is an integer, and it's exactly the same as we had. So same thing we're doing here, just with a node. And here we're doing with vex, but it's exactly the same. Don't be scared. We're not doing like really complex thing, but it's really important to understand that creating attributes, it's much easier, and you have much more control with vex expressions than with just creating the attribute and trying to put something here that works. Okay, so now we have that. I will save that as geometry geo intro scene. And let's see you in the next one. Okay, so let's start looking at some character and geometry stuff so we can do something much more complex and great. Let's say we have here a sphere and it has lots of subdivisions, has lots of polygons. And in Houdini, we have a lot of deformers. One of them is called mountain, which is, as you can imagine, it used it's used to make mountains or rocks or things like that, where you can change the amplitude of the deformation, the element size. So smaller this size, the more detail it will have, and obviously the more um, resolution you have, the better it will look. So let's say this is some kind of rock that we want to do. So this is great. It's just a deformation. Don't think of it as a rock. Think of it as wherever you want to be. So as we saw, we can create a blend shape right here and just do something like that. Just remember, clear, and update. So we have this mountain, and now we can do a blend shape between them. So a blend shape, what really is, it's just a linear interpolation between the position of this one and the position of that one, right? And then we have blending. So this is 100% this, and this is 100% this, and with a linear interpolation, this is the half point between them. Okay, great. So we can create our own blend shape node, sure, with a wrangle, and let's just add this one in the first input and that one in the second input. Okay. So what we want to change here is an attribute called P that we already know. Now, this is the position of the points attribute. So if I say that P equals at this one, and this P is the first one, so it's always the first. So to get the P for the second one, you can do just OP input 1, because this is like programming. So this one will be OP input 0, but you don't have to put it. So it's just P. So this will be OP input 1, OP input 2, OP input 3, and underscore the attribute that you want. In this case is P. So if I do just that, well, you have the mountain right there. So we need to interpolate between them. There's a lot of things that you can do in Vex, really, but blend shape is just a linear interpolation. And if any one of you know a little bit about Unreal, you probably have heard the word lerp, which is linear interpolation, really. So we can do lerps here also. You use lerps in Unreal for a lot of things, especially in shading, but we can create here a lerp. You will see that if I start typing something, Houdini says, okay, you want to do a lerp. Great. And also, if I open brackets, it gives you what you can put in this function called lerp. So you will have one float value, another float value, and the amount. Great. It can be also a vector. In this case, P is a vector, so that's great. It's 3 floats. So this value, and then a float amount to do it like that. And you can even put a vector amount if you want. So let's create just this one with that. So P would be a lerp between the position we already are, P, this, the position that is coming from the first input, well, the second input really, and a float. Let's put something like that. So you will see that this is exactly the same as doing this. They are the same. Okay, so now we can put a number here, but we cannot play with that. So we have to create another attribute. We can create attributes here in a couple of ways. So we can create this at mix, and just to be sure, I will put an F at the beginning. And just because I'm declaring a new attribute, it's just like the same that we did creating the attribute, a new attribute called mix. This time we're doing it in a Rango with Vex pretty easily. And let's say this is 0.5. And now we will say that this is no longer a value, this is an attribute. So let's put here mix and nothing will change. But now I can change this number and you will see that it changes. So if it's 0.9, it's almost the, well, the end of the mountain. It will be like that. These are exactly the same. Great. But this is not really useful, right? And there's another way of doing that. Instead of using the add mix, we can just say something like that. Well, just before that, look at that and you will see we have a point attribute called mixed. So if we want the attribute to travel across our tree, we have to create it like that because this is writing an attribute that lives with the geometry. And as you can see, I can do whatever things I want here, maybe subdivision and again, smooth, something like that. And if I look, I have my mix attribute always. But in this case, the mix attribute, I don't want it to travel because I don't need the mix attribute just after this node. I just need it in the node. So the other way to create that is just to write float mix. It's that, and this can be called mix. So it's exactly the same, it looks exactly the same, but now I don't have the attribute traveling with me. This is really important because sometimes you end up with a lot of attributes, and when you write that down to disk, to whatever format you want, Alembic or the native BG from Houdini, it's going to make it a lot heavier because it has to record this attribute that right now is on all the points. I cannot see it here, but if I just go back to add mix with a float, and this will be mix, if not, it will give an error. Okay, now I can try and show this mix attribute. And he thinks that this float is some kind of number. That's why it looks like that. Well, some kind of color. So let's change it to marker. And you will see that all the points have a 0.9 value. Okay. So let's just do the other way. Float. Let me just try to write it as should. Float mix. And now we don't have a mix attribute. So this is no longer useful. And that's great. But we don't want that. We want to create something. So the nice thing about Houdini, it has a lot of nice things. There's a really nice thing about Houdini is that you can customize everything and edit everything that you want. So let's just create here a new channel, which is a channel float because it's a float. And let's open and see what can we do with the channels. A channel is everything that can be editable, like translate X or scale Y. All of that are channels. So you can see that there's a string channel, and that's pretty much it. So let's just put a string there. String is it's characters. So let's call it, I don't know, mountain mixture. Oh, and semicolon. Yeah. So nothing has happened really. But if I click just this button, let's see, oh, I have a mountain mixer right here. And now I have a blend shape because now this is a variable, which is a channel that can be edited on the fly. So I can just alt click and create an animated blend shape right there. And you will see this does that. That is great. Let's delete that. So we created with just a couple of lines blend shape. We can delete it. Okay, let's continue. Shift S to get my nice curves. And let's say this is working pretty nicely. Well, this is working pretty nicely, but I don't want that. I want a blend shape, but with something paint on it. So I have a mask. And this is really important because in character work, we are doing that all the time. Absolutely all the time. So I will present to you one of the best nodes and the most useful nodes that there are in Houdini, which is called attribute paint. Here I'm creating an attribute and painting it at the same time. So as you can see here, there's no attribute called mask. And as soon as I just connect that and look at that, we already have an attribute mask. Okay, we can try and look at it. And right now it seems blue, but it's not blue, it's 0. But Houdini likes to show the attributes like that in an infrared thing that they have. So you can see right here, it's trying to display these attributes because remember, this is a visualizer, it's only displaying this attribute called mask as a color, as a ramped attribute with a min of 0 and max of 1, and the type of that is infrared, this one. We can change that, and we will in just a moment. So let's just hit enter. And every time you're in any tool, when you hit enter, it activates the tool in the viewport. So now you can see everything that you can do. So as you can see, we can change the radius, and we also can change how we paint it. We can paint it as volume, as a surface. So we just paint the surface. If I put volume here and I paint like that, you will see it will paint the other side also because it's a volume. Everything that's inside this sphere is painted. And the surface is not doing that, it's just what the surface does. So we also have screens, so we are doing everything in screen space across the object. We also have fill to fill it, and we also have nearest point that I really don't know what it does that much, but I never use it. Okay, let's just read critical changes and keep it with the volume now. And right now I'm painting a foreground float value of 1. So if I left click, I have 1. As you can see here, to paint is left click. To shift plane, shift left click will be smooth it. So I can smooth the values. And control left click will be painted the background value, which is this one. A little bit like Photoshop when you can paint with the first color or the second color that you have in the palette. So it's exactly the same. Great. And I'm seeing this as an infrared. So red is 1 and this kind of blue is 0. And this is all the values that are in between. It's really useful and you get used to it pretty quickly. But if you don't want to look at it like that, you can always change that, and maybe you're more used to grayscale like in Maya. So this will be like painting an attribute in Maya. 0 is black, 1 is white, and that's it. And gray areas are in between points. And for sure, it's a paint, so you shouldn't do that. But just for you to know that it exists, I can show the values. So as you can see, here are 1, here are these gray values. So this will be 0.9, and the others will be almost 0, and this is 0 because it's not painted at all. Okay, let's go back to color. Sometimes this happens. Don't be too scared. You can just do that and reset the tool. Just like an IT solution. Just turn it off and turn it back on. Okay, so I like this one. Yeah, let's just clear that, and I will just paint like the upper part of it. Okay, and maybe I will paint a little bit 0.5. Okay, so we can see that something's happening here, and the rest will be 0. Great. So I have an attribute that is called mask. You can paint a lot of attributes. I'm painting floats because attribute paint works on floats, but you can paint colors if you want, vectors, which are colors, RGB, X, Y, Z, whatever, 3 floats. Let's start with just 1 float. Okay, so now I have this attribute called mask. That's great. And that will travel because it's an at attribute, not this kind of attribute without the at right here. Okay, so now I can connect that. And now we have this attribute here. So I guess that you can imagine what we can do is grab this mixture and multiply it for a mask. And this mask will be a mask, our sorry, our attribute. And you can see I have a blend shape, but I can paint the influence of that blend shape. This right here should be, I guess, I can see it here, yeah, like this value. And I can go back to the paint attribute and maybe paint 0.1 in here, and you will see that this is working. Also, maybe you have like this huge step here. You can shift and create a smooth for sure. And even I can just hide everything and just shift and smooth. And I'm not smoothing as a sculptor, I'm just smoothing this attribute. So this is one way of doing it, sure, but this is Houdini. You can do everything procedurally. So what we can do is come here to this attribute and add, for example, an attribute blur or smooth if you want. Yeah, it's exactly the same. So by default, the attribute blur wants to blur the P attribute. No, I want the mask, so I have it here. Don't worry if you start doing an attribute blur and you want to get your mask and there's nothing here. You have to connect it, and sometimes you have to see it for it to read the mask attribute or whatever attribute you want to. So let's take a look, and this is not the same. Let's bypass that to see how I'm really smoothing it out, and let's do something like that so it's pretty smooth. You can play with the step size also, or with the time of the type of blurring that you want, but this works pretty nicely in most cases. And you can pin the border points if you have borders. So if you have like a body with the head and the hands cut out, and the pin and the border points will be pinned, so it will not change the value of one or whatever you need. So let's just add this here, and now our blend shape will be much smoother. As you can see, I can bypass the attribute and you will see where I painted, and here you cannot see anything and everything is just kind of flowing naturally. Great. This is pretty important because in character work we're doing that all the time. We're playing a lot with painted masks and blurring masks for sure, and mixing a couple of things. Okay, so I will, yeah, I think I will stop it right here. I will save that one as a paint, painted, that's called painted blend shape. Shape, okay. Oh, I was doing that. That's all. Painted blend shape B1. Okay, so now that we have that, we will go to the next. See you in the next one. Okay, so let's go again with the geometry, as you already know, and let's create the tube now. We have a lot of things with the tube, a lot of stuff to do. We can create the end caps or not. You can see right here. We can change the subdivisions there. We can change the radius, everything, just the radius in one point or the other. Lots of stuff that you can do. Okay, let's put a bit more. That is great. And I will add a subdivide node right here. And you can see it's not really great. I don't know if there's something to create the end caps. Yeah, something like that. Okay. We'll keep it that way. Okay. So let's add a little bit more points here. So we have nice squared. They're not squared. Yeah. Now they're squared. Okay. Don't be too shy with the geometry. Houdini can handle a lot of points and a lot of topology, so don't worry too much about that. Just worry if everything starts to get really slow, then you have to worry. Okay. And first of all, I wanted to explain this on the UI pretty quickly. So as you already know, this is for locking the camera. This is for lighting. All those are for lighting, so no lighting at all. And basic lighting and more complicated lighting, you can just try high quality lighting, and with the right click, you can add ambient occlusion, you can add lights and whatever, looking at that very nicely. This is visibility controls. I don't use that thing. And this is for visualizing things like, in this case, the points. So I can see all the points. We can see the normals right there. And these are for velocities and point trails and point numbers. The same thing that we did, but we can just do it right here. And you can see also here, you have the primitive normals. This is the point normals, and so on and so forth. You have a lot of things to play with, but this is just to backface, just, I don't know, backface and geometry. So if you do that, oh, sorry, don't worry if you click on these middle things in the interface. Don't worry about that. You know, you can always go back wherever it was. You haven't breaking anything. So now, right now, you can see that the backface geometry is blue. So I can see backface geometry or not. I can see it with the UV texture on it or not. This is just for display. Okay. So now that we have that, we can create a bend again. So now we have bend. This is not working, but maybe we can do that. And as you can see, I can pinpoint some points there. So let's just do something like that. Maybe here, oh, sorry, from here to here. So I have a nice bending right there. That's great. Okay, so now that we have that, we can start playing with something. One thing that it's really the bread and butter for character workflows is the remesh node. I will show it just right now, and I will create a remesh node here, and you will see what it does. Okay, now it's remeshing our geometry with a target size of 0.2. Yeah. So this is the triangle. This triangle is 0.2. Let's put 0.1, and you will see the triangles are smaller and then smaller. And because, as you know, Houdini works in meters, this is a lot, but this is like putting 2 units in Maya, 2 centimeters. So now we have exactly the same, roughly the same volume, but with these points. Why is this important? Because right now, if I look at these have 15,000 points, 15,000 primitive, right? So this is a lot. And this one has just 1,000 points and 3,000 primitives. This is much better to work with. So maybe, just maybe, we can create this bend again. We can just play with the bend with this one, and this is going to be much faster to calculate. And we can just use that to create this bend and make this remeshed geometry move this much more subdivided mesh. Okay, so how do you do that? You do that using an amazing node, which is called point deform. So point deform, as you can see, it needs 3. It just needs 2 input, but you really need the third one, and which are like the mesh to deform, and the rest point lattice, and the deform or moving point lattice. So what we need is mesh to deform, which is this one, a rest point lattice that should be in exactly the same position or the same volumes as the original one, which will be this one, and a deform lattice will be the one that I'm putting in the middle, but deformed. So it will be this. So now I can just put it here, and you can see we have our geometry deformed. just think of it almost as a wrap, but it's not only a wrap, it's doing a lot of things. As you can see, there's a lot of points. It has a minimum point number of 1, maximum point number of 100. This is kind of smoothing out the deformation, so it's great for some things. Maybe you want, no, just get 1 point. I don't know if you can see, but yeah, you can see some difference here because I have a lot less points here. So it's trying to get just 1 point for per point. So every one of these points are just grabbing 1 point here instead of 100. And you can see if I put 25, it starts to smooth a little bit more. And maybe with 100, it's perfectly smooth. So this is almost like the same of doing a delta mesh, which is a deformer that already exists in Maya and in all those softwares. So maybe I can just do that and try to add a delta mesh. And you will see it will change a little bit the points in the pins, in the border, but everything looks pretty nicely smooth because this is what the delta mesh does. So you can see this is a delta mesh. Great. Let's keep it that way, just as an example. So now I have that. And obviously, I can just grab this and do here in the angle. Maybe I'll click it and maybe we'll do some animation there and some other animation right there and maybe something here. Okay, something like that. And at the end of everything will be 0. So I have this amazing animation. Okay. This goes until 96. So let's put 100 right here. And okay, so now this is moving. I'm animating this one, so this is pretty fast. Let's see if I can click that. This is deforming this geometry at more than 120 frames per second. So this is pretty fast. And when I deform it and I delta mesh it, you will see that it's still 120 because it's not that much. But if you have a lot of geometry here, you will see a huge change. So it's pretty important to get the remesh done. It's important to understand that the remesh should be done before the formation because if I do that after the deformation, let's just do it, everything will change. I think you can see some points changing right here. So for each frame, it's created a new remesh. So it's creating a new ID of each point, a new PTNAM. So it's not going to work at all because this requires the same point number from this input and this input. Not the first one, but these two have to be blade shapeable. They have to have exactly the same point number and order. Okay, so now that we have that, we can start talking about the remesh node. Remesh node is really good, so it really works. Let's just try and do something like that. Let me just paint an attribute. Attribute paint, and I will call it, yeah, why not? We'll call it mix. Whatever. Okay. And hit you and start painting, and I will paint just the top of my cylinder. Great. So as you can see with the remesh node, we have the mix attribute painted. That's amazing. It has a copy attribute inside, so this is working. That's amazing. That's pretty good. So we can try and play with that a little bit. Let's just delete these ones for now. Maybe just do that. And start talking about what I'm doing here. So what I'm doing here is a deformation, right? I have a bend, and maybe I will mix it with other things. So let's imagine I want to do, I don't know, a mountain. Yeah, another mountain. So let's try and add a mountain right here. So we want this kind of cylinder to be bent, right? Okay, that's great. Let's put something like that and just a little bit of mountain. Don't worry about these end caps. This is not a problem at all. But let's just do something like that. Great. I don't want to see the mix. Okay, so when I do the remesh, it keeps the shape, but it's not exactly the same, but well, it's working. It's working. So I have this thing going on. That's great. So as we know, we have the mix attribute right here. Everything is where it should be. So let's say I want to keep this kind of detail on the top where my mix is, and I don't want it on the bottom. Okay, so my remesh is trying to get this, everything is exactly the same size. As you can see here, every point is like that because it's a uniform thing. Oh, and by the way, this is the edge length of its length of the triangles. So I can change it to adaptive and it will try to match something here. And we have some control attributes. So let's say I want to use the mix attribute to control the remesh right here. So let's just type mix right there. And you will see that it's going to crash. When it's cooking and something doesn't work, just hit escape and it will stop the remeshing. And you know, this is not Maya, this is an amazing software, so this doesn't hang up. If you have some hangups in Houdini, it's your fault, usually. That's the problem here. He was trying to do um, a remesh with a value of the size of 0. So it will be a lot. So a lot of points. It will try to create a lot of points on the lowest value it can. So this mix attribute is not working for that. Okay, let's paint another attribute. Let's keep this mix attribute for now. And I will just go here to attributes and paint another one. And this will be called remesh. Okay, so let's just paint the remesh attribute, and we know we cannot put it to 0. So what is a good value for the remesh? Just hit escape right now and just put it in uniform. What's a good value for the remesh? So 0.02, it's a good value for everything, but if I want to go really deep on detail, maybe 0.05 is a great value. So let's just go here in my remesh attribute and let's paint a value of 0.05, right? And let's just do that and fill it. And nothing's changing. Okay, what happened? Well, let's paint the other one, 0.02. That's what I want. And let's paint here. Seems that nothing's happening. But I guess I'm painting something, right? Let's take a look at that. And let's put it on a marker. Yeah, this is 0.02 and this is 0.05. So this is nice, but you cannot see it because this color has a min and max value of 0. So if I put that to 0.2, you will see the difference. And now you'll see that I was painting something. When I paint 0.02, this is working. So let's put a max of 0.02 and you will see even better. And as you can see, it's not red anymore because the red is the max value. So this is the max value and this is much more. So, well, this is much less. So something like that. And I cannot see the difference because I'm clamping the max value that I'm just showing here. So this is just to keep in mind that we can paint a lot of things, but you have to be careful on what you're displaying, right? If I have this 0.02 and 0.05 thing painted here, I can just grab this one and say that I want it adaptive. Just hit escape because I don't want it with this node, and I want the remesh attribute that I have done. And you've got it. So now I have this remesh up here, a lot of remeshing. It's just like if I just put here 0.02, something like that. Yeah, because it's the value that I painted. No, 0.05, sorry about that. I'm just forgetting the numbers that I put here. Yeah, so these and these should be the same size. And these ones will be as if I put here 0.02. Okay, you can see it's the same size right here. Because I can do the attribute, I can do a remesh, adaptive remesh. That's great. But painting these numbers is not really easy. So what we can do is we can just delete this remesh attribute. I don't want it here. Just delete it. We have our mix attribute, and that's the one that we wanted to use, but it has really different values, and 0 cannot be a value, and 1 cannot be a value. What we can do is just remap, and we are doing that a lot in character work. Remap this. So what's a remap? Remap is exactly what it looks like. So the input was 0 and 1. Yeah, but now I want that when I had 0, let's put 0.02. And when I have 1, let's point 0.005. And let's change the name because the original name was mix and I want that called remesh. And now I'm creating a new attribute called remesh that looks like that because he remembers that this was my mix and max point, but if that was like that, you cannot see almost anything, but you know it's working and you can for sure change the visual representation of that just as was. So now I have exactly the same attribute paint. So here you can see I can keep painting just 0 and 1s, which is much, much easier, and it can work for a lot of stuff. Let's keep it like that. That's great. And it's obviously updating the remap. So now I can have my remesh like that. This has 0.02, 0.05, 0.005, sorry about that, and 0.02. That's great. And I can also create something like that. And I have this. And maybe, just maybe, we can do exactly the same thing that we did before, which is creating a wrangle. And let's do the same thing. So I have this here, I have this here. Let's create a blend shape. So P is equal to alert of P and OP input 1P, and let's multiply it by mix. So now this is not happening because my mix attribute is multiplying that. Only the geometry that is with the mix and each remesh as it should is deforming and the other one is not deforming. So of course we can just grab this attribute paint mix, and as we did before, we can add an attribute blur by painting. Let's blur the mix attribute and let's see what happens. So it will change not only the blend shape, but also the remesh because we have this remap right there. As you can see, it's trying to get closer and closer, and I have much more resolution here than I had without the blur because it's trying to, let's do a lot. It's trying to blur everything out. So let's do something like that. Okay, so now I'm blurring the detail. At the same time, I'm blurring the deformation and the remesh. So that's pretty nice. You can see right there, this is another thing. And obviously, because we have exactly the same, we can create a point deform. So let's create a point deform. Where? Just before our remesh, because we want this mesh to be deformed. So let's just grab this mesh and put it like that. And now I have this one right there, but sometimes you don't have this exact position. You should, but sometimes you don't have it. And my animation is not tactile like that. That is why we need a pre-roll in every animation or simulation that we have. But I know for a fact that the last frame is the frame that we need. This frame is exactly that because the bend is at 0. So what I will do, and we do that a lot in character work, is do a timesheet, and I can change the frames here. This is by default with the expression $frame, but I can change it and maybe delete the channel and keep it just this frame. So now this is not moving and this is moving. So because this frame is in the same position as this one, but with this remesh geometry, I can just grab that and use it as a respawn lattice. And this one will be the one that I'm going to use, just create something that is nicer for the point of form. So now we have our geometry. As you can see, the delta mesh is doing too much. You can see by just disconnect the delta mesh. So what can we do? Well, we could grab, because delta mesh has a reference geometry. This is smoothing to match, and I want this to be my reference geometry, right? So let's try and grab it where it should be. So this one is pretty nicely, it's pretty nice, and this one is not. So let's just grab this one and do the same thing. I just Alt and drag and create that one. This will be in frame 1, and this is my reference geometry. And now my delta mesh, as you can see, is trying to smooth everything out, but using this as a reference. So this curve is much smoother, not that much, you cannot see that much, but when it starts deformating, I guess that you can see it. There's a little bit of difference, not that much really, because there's a lot of points here, but we have something that more or less works. Okay, this is great. Let me just show you one thing. Let's see what happens if this first frame is, let's just put that at 0. So we have this. That's great, because now I have this can be also the first frame, and everything is the first frame. So having that, maybe I don't want to use that, and I want to use this, because this is the same topology, and we have here the same topology, but what we want to keep is this one for the delta mesh. So how can I do that? I can, for sure, do something like that and create some points and do some stuff here. And now this will be working exactly the same. That's great. But you can see the difference. But this can be really, really tricky and complicated, and lots of clients doing that. So that's why Houdini has an amazing node, an amazing workflow for doing that, which is with the node object merge. This is calling another node in the same graph or in other graphs. So you can call whatever you want. So let's just grab this node right here and Control C, and let's go here and say that the object you want is that. Okay, so this is exactly the same as this. You can see it. This is just to not get a lot of lines there. So I have a direct connection there. You can do that with Control C, Control V. You can do that by looking at the node itself. This is the mountain one, so let's grab this one. That's exactly the same. Or you can do that just by dragging this up here. And this, just keep in mind, this has changed. So when I selected the node, let's just select the node and hit mountain. This is object GO1 mountain. That's great. If I just hit Control C here and I put Control V here, exactly the same thing. But when I drag it, look at that. What's that? Well, that is a relative path. I told you that Houdini always works with absolute paths. That's not entirely true, but it really is. But this is not really, this is a relative path that means that wherever called mountain one in the same scene I am in, the same context, sorry, I am. So this will be mountain y here in the geometry. If I was inside two different nodes, this will be something like that, and so on and so forth. So this means in this folder, to say something that it's easy to understand. In this folder, find something that is called mountain one, and this will be what I'm looking for. We'll see the difference between using this kind of paths and absolute paths in a bit, but just for now, you can understand that I can do that. My delta mesh is already working, and I just learned how to point deform something with a variable, remeshed, and blend shape all at the same time, all with everything using the attribute paint and the attribute remap. This node is amazing to do this kind of remaps because it also comes with a ramp. So you can change how these two input and output values are played just with a linear ramp, or you can play with it and create crazy stuff here. We will be doing ramps in a second, but for now, I think this is it, and see you in the next one. Okay, so let's try to do a fairly more complicated thing right now. I will create a grid and put a lot of topology there, something like that, not that much. And I will do Alt and another geo, and here maybe I will create a sphere. Okay, so now that we have these two nodes, we can try and see if maybe I will just reduce that and put the center a little bit upper so we have something like that. That's great. Okay, so we have an attribute that we haven't spoke about, and this is called color. As you create this color attribute, you will see that I can paint some color in the geometry. This doesn't have anything to do with shading. You can use attributes that you paint in shading for sure, but this is just for shading. And you can see that my color is called CD with capital C. Okay, this is the attribute called color. So as you can imagine, we can create the same with Rango. And because this is a Houdini attribute, we can create CD with C equals, and let's put here a vector like that. And this is going to be red. Of course, this is going to be green, and this is going to be blue for sure. So let's try and do some animation here. I will add a transform node to transform it and create some animation. So maybe we'll start, I don't know, something like that. Oh, something like that. That's great. And let's do 100 frames, something like that. Yeah. And this will be here. Great. Let's put 100 frames here, here. Let's put it in real time, and you will see this is working. That's great. So let's imagine I want to do something to my geometry right here using this ball, right? So this is an excuse to show you an amazing tool, which is the copy attribute or the transfer attribute in this case. Okay, so I will create here a node. This is a thing that we do a lot, which this doesn't do anything, but it's for export things. And I will put out in capital letters, out or out ball. Right. Okay, so this is going to be out what this will export. Okay, so let's just put here ball, and let's put here ground something. Okay, and now we will call this attribute, this object ball. So let's give it an object merge, and now we can find inside of ball, and you can see that because I put capital letters is the first one. So it's really nice to name your things with capital letters when you want to get out something. So this is out ball. That's great, and you will see it. Oh, but by the way, if I'm inside an object, now I'm in the grid, but I'm seeing this ball. This is because I have all objects shown when I'm inside something. I can hide, and I'm just looking this object, this geometry shop that we are in, and I can ghost, so I have the ghost of the other object, the ball object that I have here, or I can show it and I I can see it. So if I hide it, you can see that this is my ball right there, and this is my grid. Great. So let's add a color node. Let's make it black, right? And let's try a transfer attribute. Attribute transfer. Okay, so this is the attribute, the geometry that gets the attribute, and this is the geometry that gives the attribute. So right now, I'm going to just transfer the color attribute, and as you can see, this is blue. This is because the ratio here, the distance threshold, is so big. I can just go like that, and what I'm doing right now is transferring the color attribute from the sphere to the grid. So you can see it right here. This is working. Nice. So what I can do with that is maybe a little bit less, and maybe I can just put something higher here so we have much resolution there. So I can create some things there. So just as an example, now I have this CD, this color, which is 0 in red, 0 in green, and this sphere is in blue. So in blue, it's going like that. Great. Let's keep it that maybe, and we will put here another thing. Maybe we can just put a peak, right? Peak node. It's a node that just moves object on their normal. So it's like an inflate. So let's put something like that, maybe a little bit more. Something like that. Great. So now what I can do is I can do exactly the same thing that we have been doing, just for you to understand this is really, really important. So that's why I'm doing that all the time. So I will do a lerp, and this lerp is going to be between points and the OP input 1 points, and we will use as mask cd.b, which is blue, or cd.z, which really is the same. It's just the last float of the 3 of the vector. Great. So what I want to do is I want to grab this, which has this color attribute right here, and put it in the 1, and this one, and put it in the 2. Oh. And as you can see, we have that going on. Let's just override the color right there. Maybe I can just override the color after this deformation, because this is script, this is programming. It goes from up to down. So it first will execute this one, and then it will execute another one, which will be that CD is equal to white. Let's just put something like that. Yeah, so now it's white. So now you can see we are deforming our geometry with that. That's pretty nice. So if I grab the sphere and this ball, and I just show everything, and I change its position with this transform node, I can hit enter and I have a transform value, you will see that everything works. So now this is doing this. It seems like it's not updating, but as soon as I just go back, you will see everything is updating. So this is great. And for sure, this doesn't look that fine, but as you know, we can play a lot with that. So this is the attribute we're using. Let me put that in another way. Maybe we can just do something like that. It's going to be easier to read, maybe. And this is my ball. We are transferring the attribute using the color, and this is the peak, so it's the formation, and we're blending them together like that. So we can grab this attribute and do an attribute blur, done for lots of things. And let's blur it a little bit. And this is not the P, I want to blur CD. And as you can see, because I'm blurring this attribute, this color right here, this looks like that, so it's much smoother. So now I have this kind of mole going up and down just transferring the attribute. And you can understand we can do crazy, crazy stuff with that. So we can even create, I don't know, not only a peak, but also a mountain. And let's just grab this amazing mountain that it does. This is pretty great. This is why mountain looks that really, really good. If you have topology and you have a plane, it creates this amazing thing. So you can see now I have this mountain just doing that. This is pretty great. Maybe I can even just do an element size, something smaller, maybe not that much, something like that. And it looks really awesome. And we're doing crazy, crazy stuff just with a couple of nodes, really. So this was just to understand that we can transfer the attributes and do some stuff. So one thing I want to be really clear, and I will just put it here just for you to understand. So this right here, I will put a sticky note right there, and I will say this is world space transfer. Okay, so we have two more nodes that make exactly the same thing, but that are not wall spaced. So we have another one that is point or vertex over transfer, which is if you have two geometries with the same point number, they are rotatable, you can transfer attributes using this node called copy attribute. So it's exactly the same, but it will copy between two geometries that has the same point at the same point order. Okay, and lastly, we have one that is the UV transfer. So there's this transfer attribute by UVs that will do exactly the same thing. It will transfer the attribute that you want using the UVs. So you don't need the same geometry, really. You don't need the same wall space, and you can copy one attribute from one geometry to the other using the UVs. This is pretty important because if you break all three, there's nothing to do. There's really nothing to do, and you have broken everything. If you have at least one of them, you're safe. You can transfer whatever you need. Because if I have the same UVs, I can transfer the P attribute. So if I have the same P attribute, I have the same wall space. If I have broken the wall space, but I have the same point order, I can just copy the P attribute and I will have the same wall space. So you can do anything when you have just one of them. And just keep in mind that if we put that in order, this would be the order. So wall space is the weakest one, and point order, vertex order is the strongest one, always. Okay, I will save that just for you to remind, and let's put here some transfer attributes. One, and then we'll go to the next one. Okay, so let's start loading our first character right here. I just create a geo node, and Houdini comes with some test characters already. So let's grab this one, and let's see what this does. As you can see, this is this capybara, this creature, and nothing's happening. It has a lot of things here to change, but it doesn't think to do anything at all, right? And it has like three outputs. Let's see with a node what they are. Usually what you're seeing is the first output. So we can see this is that, nothing's done right here. This is some kind of skeleton, right? It looks like a skeleton in the default pose, the rest pose, and this is a skeleton that, oh, this one is moving. And if I click here, this one is moving, okay, in a direction. That's great. If I click here, oh, there's a lot of things. This is a motion clip, so it's a loop, I guess. And let's see what happens if I change that. Muscles, bones, skin, add shader, not shader, normal maps, surface. This would be for shading, I guess. I have some transformations right there. That's great. So this right here, it's called HDA. You can see it right here. If you don't see these right here, just go to Assets, Asset Definition Toolbar, so HDA Toolbar, Show Menu Always, and you can see that this is going to my installation because it comes with Houdini and it's called placeholder or whatever. Okay, so, and the asset name is Test Geometry Capilla. Great. So there's a thing in this geometry called bone capture. You can see right here. We cannot see the attribute itself because it's a really strange attribute. It has capture 11 unique points or whatever. And what this really is like the skin weights in Maya. So this geometry is already weighted. They put some weights and paint some weights for each one of the joints. So it's already weighted. And that's how you will read an FBX, for example, that you download or whatever, or that you just export from Maya, and it's not moving really. And it's not moving because Houdini has two nodes for that. This bone capture, which is the paint node to write this attribute, and then along in the tree or wherever you want, you can have the bone deform. The bone deform is the one that makes the deformation. This capture just paints the attributes, the relationship between the bones and the skin, and this bone deform is the one that deforms it. So it needs a geometry to deform, a rest point, and a deforming point. Transform. So let's just grab these three. This is the rest. Remember, this is the one that's moving, and you got it. I put the shader because it's nice. And now I have this walking. And if I apply the locomotion, you will see this is going like that. That's pretty great. So this is how you do something like bone deformation, skin deformation. We will not learn how to skin weight and anything in Houdini because it's not that easy right now. It's much more complex. It's easier to do. And right now the industry is doing everything in Maya, but you should know how to read it and how to reproduce that here. You can even see that in the bone deform, you can change between dual quaternion or blending between dual quaternion or use the input right here. It doesn't have an input for the skinning method, which should be another attribute called skinning method. But we have something that moves. Okay, we have our first character. Now we will try to do exactly the same that we did before with the sphere, but with this character, and we will create an HDA to do that. So how can we do that? Okay, so one thing that we need for sure is a grid. We know, let's just see our grid. Let's make it a little bit, not like that, but maybe like that. Okay, that is great. And now I will put some crazy numbers here, something like that. Maybe that's too much, I don't know. But yeah, something. That's good. So I have a lot of resolution here. Maybe we don't need that much resolution, but we will see. So first things first, we know that we want to see both of them at the same time. So we have a node called merge. Well, we can merge a couple of geometry, and you will almost always have this information node, this warning right here, because I have one object here that has some attributes like shot material path, UVs, name, whatever. A lot of attributes that I have here. Also the P, the name, the shot materials, whatever. And here I don't have them. So if they don't have exactly the same attributes, it will do this warning, but don't worry about that. We're just using it to visualize it. So let me just grab these, and I don't know if I can do that. I guess I can do that. Yeah, I can start from there. So we have really great. That's a nice walking cycle. Great. Let's put 180 maybe frames. Okay. So if you don't want to do that, you can just template this one, see it, or maybe the other way around. Template this one. Oh, sorry. Template this one. You hit Control and template. You will template it with solid as it is. So it's another way of looking at that. And the nice thing about that is I can keep working with that, and this will always be templated. So I will be always looking at that. So first thing first, we need something to do a remesh of that, because I want to remesh it to get the maximum amount of detail that we can. We could for sure create a curve from that. I will be showing curves in the other part of the tutorial for the vellum, but right now I will be just doing, I don't know, maybe a cube. Let's do it. Okay, so now I can also do that, and maybe I can bring it up a little bit and make it really big in Z. So that's pretty nice. Okay, so now that I have that, and this is in the same place, you can shift and have a couple of them. So these will be in the same place that this character is just walking. So let's try and create a group from there. So let's add a group, right? And let's put a bounding object, which is this box. So now I can create a point group from these bounding objects. So let's just create this group as it is. And oh, by the way, you can use the bounding box or the bounding object that you have created. So this really doesn't matter anymore. I can just delete that one. I just wanted to show it to you, but you can also use the bounding box and just scale that one. But let's keep it like that. So I have all these points selected, right? And these are going to be called group 1, let's say path group. So I have a group of points that I can play with, right? Okay, so I can create, let's create just an attribute wrangle, and we'll create a couple of them. So I will create an attribute for remesh that it's called remesh. Just as before, this is going to be a float, and let's put a value of 0.2, something like that. This is, I think this is too much. It was 0.02, right? And let's do a remesh right here. And this remesh will be just using this attribute, the attribute that is called remesh. And now it's calculating the remesh. I think it's too much, maybe it's too much. Let him calculate the remeshing. As you can see down here, it's remeshing everything. And I think that's a little bit too much. Yeah, this is too much. As you can see, it's doing a remesh that it's a lot. So I can just change this and put something like 0.1, maybe. Yeah, that's better. Okay, that's great. So I have that. And maybe we can play with that. We can just duplicate this. We'll see. And I will connect it. And I will use this path group to put here a much lower value. So now you can see we have this adaptive remesh with the group that we did. And now we have much more detail. Let's just put it like that. Much more detail in the action zone of our character. That's great. So we created a group using that bounding box, and this is why Houdini is so procedural. So we can just grab this box and change its size, and you will see, maybe if I put 2 here, now this is my remesh, and now this is my remesh, and this can be changed a lot. Okay, this is great using this box. So now that we have our remesh, what we can do is create, I know it's just right here, but just we will change some things. So let's just create here an all And let's just say this is the out geo or the out character, whatever. And let's create an object merge right here of this one. Okay, that's great. And now what I will do is I will create a color node there. And this is not working because it already has the shader and everything. So you will see here that we have the shop material paths and all of that. So what I will do, it's an attribute delete, which is an amazing thing to do always, because if you don't do that, sometimes you're exporting and you're traveling along the tree with lots of attributes. So I will delete all of attributes. An asterisk is deleting every attribute. And now, as you can see, I don't have anything. So I can now change the color, and I don't know what's happening here. Why it's not doing that? I'm seeing this one. Okay. So now I have a really clean geometry that just has color, white color, and the P, the position. So this is great. Let's put it again, red. Let's put that black, and let's do exactly the same thing that we did. So let's put some attribute transfer, and let's transfer the color, just the color right there. And again, we will need to get this something. Okay, maybe this is like a nice default value. So now we have our character moving. That's amazing. Great. Let's try and do the same thing that we did. So let's just create a mountain right there. You will see that the mountain is much more defined here because it has more points than outside. So this is great. Let's just hide the grid for that. Okay, and as you know, we can just grab all of these and this mountain. Let's see where to put that. Sometimes you have crossing things. It's really hard to not have crossing stuff, but let's just try to be a little bit more organized here. That's great. And let's do, as we know, an attribute wrangle and do exactly the same thing that we have done. So this will be the P is equal to alert between P and OP input on input 1P, and this will be multiplied by CVX column. And now we got, but this is not looking pretty nicely. So let's add color right here, and maybe I will add a wrangle to create a node, to create an attribute, sorry. It's a float attribute that will be called displays or whatever. Displays it's equal at cd.x, the red channel, and when we need the color, we can just do cd it's equal at white. So now this is white, but we have an attribute here called displays, and this is how it looks, and it's moving. That's great. So we can change that to this new attribute we did, which is called displays. Yes, yeah. And now we have that. As you can see, this is forming, and it's doing weird stuff because we have ups and downs in this mountain, really, but it's doing what it should be done. So what we can do, obviously, as we did before, is an attribute blur. Let's add this attribute blur right here for our attribute called displays, display. So now we have this. Maybe we can add here peak, right? Just to make it grow and always be in the direction. So this is going to do something like that. That's great. maybe I can just put an element size of a mountain just a little bit like that, a little bit less there. And maybe I can create also float called mix, and this will be just a channel float, right? Called displays mix. And I will multiply that for mix. And now I can play how much I want to see of this deformation. And let's just control click here, and you will see we have our character walking and creating deformations from this mountain. Let's see if I can put something a little bit nicer here. So maybe something like that. Maybe I can just grab this remesh, the remesh attribute that I had for the group, which is that, put a little bit more. It's going to be a little bit harder to calculate, but well, here we are. That's nice. And we can play with that, blend them together. Also, we can play with the mountain amplitude. So I think it's going to be something like that. Was cool, but this is too much. So something like that. And maybe we can add some soften here if you want. We can do a lot of stuff. As you can see, it's exactly the same that we have done, but with everything in just one place. So this is great. This works, but we need something to play with it much faster. Oh, by the way, we don't want to see this geometry, which is the geometry that has all these, but we want that to be created from the original one, which is this, which is the first object that we have. So we can just drag here and create a pointer form. And we can grab the remeshed node and the form node. And now I have my original geometry deforming, as you can see. It is getting a little bit slower, but it's working. So this is my geometry right there. And maybe I can end up with a subdivision node to make it a little bit more smooth. And let's just create that and hit play, and you will see it's going to be slower. We're working with a lot of points, but everything is working. That's great. So now that I have this setup done, and this is working and it's looking pretty nicely, we haven't done anything new now. It's just putting everything that we know together, and it works. It's pretty nice, but I need something to control that. I need something to get these controls because I don't want to be touching everything separately. So how can we do that? Well, we can do that pretty easily if maybe I will create a null and I will change this form because I prefer to get it something that it's really visible from anywhere. So something like that works. And this will be controls. Okay, so now we can start controlling things. Just as an example, I will create some controls to, I don't know, maybe change this element size. So 0.01, you can see it's changing, 5 changing, 1, whatever. So maybe I want to control this, or maybe I want to control this mix between one or the other because I think this is a little bit better, right? Okay, keep in mind we're not simulating anything. We're just transferring one color to another geometry and doing a mountain and things like that. I don't want you to simulate anything per now. We'll be doing that later, but right now we're doing that. Okay, so, and let's just try and grab this attribute, okay? So I will grab this control, which has nothing, and I can click here and edit the parameter interface. Well, what is that? This is a lot of things. Yeah, I know. But it's pretty simple. really. So we can just grab attributes from here and put it there. Parameters, more than attributes. So I want to change this mix value right here, which is a float number. So let's create right here float. Here it says float, so let's just put float here. And this name will be mix displacement control, maybe, and the label can be mix displacement. Okay, that's great. And the range will be between 0 and 1, I guess, and nothing happened. Okay, let's hit apply. Oh, I have here my mix displacement. That's great. Set, and let's see what, well, this doesn't do anything because they are not connected. So let's just copy this parameter, copy parameter, and let's go here and paste relative references. So I'm going to paste this parameter. And this does an expression, which is a channel that is in controls in the same context, in the same folder I am, which is called mix displace control, which is the name that we put to this parameter right here. So now I can control from here the amplitude of this. I cannot change this number anymore. It seems that it works, but it doesn't work really. If I change well, it shouldn't work. I don't know why it's working, but well, at the end of the day, they are just the same. But the idea is not to have to go here. So same thing we can do maybe with mountain, right? Let's just grab that and edit parameter interface. Let's see if I can just grab this amplitude and put it right here. Ah, that doesn't work because it's outside of a sub-network. So I have to create another float. Let's just put another float here. Let's call it amplitude. Let's put the label. Let's call amplitude also. The range will be something like that. And let's apply and accept. So nothing has happened yet. I have to copy this parameter and paste relative references. Now this is going to control amplitude. So now I can change the amplitude right here. So this is just with the peak, and this is with the amplitude, changing the amplitude of the mountain. I guess that you understand that and how powerful it is to create some controls and do things like that. You can do that for any setup that you do. If you want to see the setup and maybe you want to change things inside the setup, this is the perfect way to do it. And you have some controls here. You will see we can create lots of crazy stuff here. Let's just grab those two, which are the default ones from the null, and make them invisible so we don't see them anymore. We can create folders, and this will create like different folders, and the name will be folder 0. That's okay. And let's say the mountain displacement. So apply it. Now I have this, and maybe I will create another one to create something like the transfer. Let's create this one. It's something like transfer. Okay. Come on. Transfer. Yeah, that's so now I have a transfer one, and then I can just create a float right here and say something like distance. I will create a range from 0 to 1, I guess. Well, it can be 0 to 10. And then I can just grab my attribute transfer, and I want this distance threshold to be controlled with that. So let's go here. Let's hit apply. So I have here that copy parameters. Let's go to the attribute transfer and paste relative references. So now this is 0, but I can just go to my transfer attribute. And here I say the default is 0.2, maybe. Okay. This won't change, but the next time I create that, it will change. So, oh yeah, change it. So this is how far our transfer will be going, the transfer attribute that we have, which is transferring the color, remember. everything is fine, everything's dandy, everything is amazing, and we have all the control that we want, and we can create a lot of this. But if you look at that, this doesn't have any control or anything outside it, and we have a lot of things to make around here. So I will stop it here, and I will show you how to create your first HDA for this kind of geometry deformation based on the character that we have done here. I will save this one as controlled terrain deformation. That. Okay, and we'll see you in the next one. Okay, so let's start from here, and let's see if we can create an HDA. So first thing first, I want to delete these controls right here. So now you can see that this is going to some place that doesn't exist anymore. So it's better to Control-C that and keep this amplitude that I have here as an example, and just delete the channels, Control-Shift left mouse. So I had that one. I had the peak, right? Yeah, I just had the attribute transfer, Control-Shift click. So we don't have that anymore. And also this one, Control-Shift click. And I think that's pretty much it, right? 1, 2, 3. Yeah, now I can delete it. Everything stays the same. Maybe this should be a little bit more. Oh, yeah, that's great. Okay, and this is working. As you can see, it's changing. Everything's working. That's really, really nice. So if we come back here, you can see this lock just right there. This means this is an HDA, and you can see this is an HDA, and you can go inside, but you cannot edit anything. That's why this is grayed out. But you can look, and you can edit if you want. So let's see what this is happening. We don't have permission to change any of that, but we can just right-click it and allow editing of content. And because this is in my computer, I can change that. You shouldn't never do something like save node type. All of those things will overwrite the amazing node that the Houdini people has created for us. So please don't do that. Just do it to look at things. So what is that? Let me just hide. I don't want to see this one. I want to see just not even this one, just this one. Okay, so let's see what we have here. So here we have a skin. This is our skin, and it got a material, which is from a material network that is just right here, just inside the same geometry tab, the geometry context. And here we have this material, which have some images and some things that are in your computer to create this nice material for our capybara. And here we have this material, and here we have another material. This will be with the skin, and this will be with no normal. I know that you cannot see anything right now, but this has a normal map, and this don't have a normal map. And this has a switch. So this switch is making a switch between 0 and 1, as you can see. And because this is like that, and this is like a per line, and this is a spotted line, this means that I'm using this one, the one with no normals. Why is that? Because here, out here, there's no normals applied. Let's apply the normals, and you will see that this is now the line that's fair. So the switch is grabbing the first input, not the 0 input, but the first. Okay, so here we have another switch, and that switch will be connected to add shader. Let's look at that, and look at that. We have an add shader here. Let's just disconnect that, and you will see now we are getting the skin, which is a BGO, which is the format that Houdini saves things. SC just means that it's a compressed one, so that's the format for Houdini files, for Houdini outputs, bgo.sc. That's really nice. So we have another switch right here, and we have 3 inputs, it seems. Right now it's on the 0, and this is output. Let's see if there's something that is called output. right here. Oh, this is called output, and you can see the name of the parameter is output. So this is skin, this is muscle. Let's go. Yeah, this is getting the one, which is the muscle, and these are the bones. That's great. You can understand what's happening anywhere. So, and this has the first output, and the first output will be the geometry. The second output, we remember, was exactly that. It has a transform that is doing something, and this has a connection with the scale, and this has connection with translate and rotate. And if we go here, you can see we have translate, rotate, and scale. So this is moving this transform right here, also this transform right here, and I'm sure that we have another transform right there. Okay, and what's that? This is our clip of animation where we can apply the locomotion, and you can see the locomotion is each one of the frames of the clip and the skeleton in every one of the frames. And we have the transform here, and also we have the motion clip evaluation right there, where the frame will be the clip that we're getting. So these all of those poses are like the 1, 2, 3, 4, and here we have the same thing with the frame. So now if I do that, we will see that just running in space. That's great. And if I try to see this one, nothing's happening. But again, this is the same switch, output clip. So this is the same thing that we have here. So let's look at that. Sorry, because I'm just changing the blue display everywhere. So let's put it here. And this will be muscle, this will be the skin, everything's great. And when I put the ball deform, you will see this is moving, that's great. And if I don't apply the locomotion, this is moving. And if I output the motion clip, nothing's happening because this is getting no animation at all. This is getting all these skeletons duplicated for each frame. Okay, so this is an HDA. They did that for us, so we can replicate this HDA pretty easily, but we will be doing our own. So let's just apply the locomotion. So we have that. We can add the shader if we want. We didn't touch anything. So let's do an HDA for that. So the thing that is most important of an HDA is the inputs. So how many inputs will you have and the outputs? Something like that will never work inside an HDA because this is grabbing this geometry from outside. So this shouldn't be here, right? Okay, there's a thing that I do before I create an HDA. It's just counting my inputs and creating nulls for them. So this should be like input, let's put it like that, input 1. So this is input 2, and there will be an input 3. So my input 1 will be that. So let's connect everything here. This is my input 2, which is the box to create the remesh and the points. And this is my character, my input 3. So let's try and grab something for that. We'll grab this one just right there and put this input 3. And what I will do is create this, another object merge here. And this one is not going to get this out channel, but the input 3. So all of that will be inside. We can for sure do something like that, but this is not as nice. It's much nicer to do that and be sure that the input 3 is loaded here and everything is going to look great. And then we will create here an output, which is called output really. And that's pretty much it. So now I can grab all of that. Let me just, in case, just connect this one because sometimes it do crazy stuff and then we will just use it afterwards. Okay, so let's select all of that and hit this box to create a subnetwork from that. Okay, now we have this. This looks really great. It has strange labels and stuff, but it looks really great. So let's see what this output, and you will see after the remesh, this will output exactly the same because we have this output right here, and this is what I'm seeing. And every time you create a subnetwork, it already creates an output for you and all the inputs for you. By default, it has 4 inputs. We just need 3 in this case, but it's good to know that this works. So this is a subnetwork. But I don't want to do a subnetwork. I want to do an HDA. It's not the same. This right now just lives on this script and on this Python file. So I want to save it as an HDA so I can load it anywhere I want. So let's just put a name here. It will be called terrain former, something like that. Okay. Every time I change the name, it will do the calculation again. And I will just right click and create digital asset, an HDA. So let's create a digital asset. This is the new digital asset folder. The new window to do some things. You can change the username. My username in my computer is user. You can change the name. You can change the version. You can do whatever you want here. You can change where it's put in. I will put it in the submenu of digital asset, so it will just be a digital asset. And where do you save it? I will save it in my C in the OTLS folder, which is the old one. Before they were called HDAs, they were called OTLS. And that's pretty much it. Let's create it. And you will see that will change a little bit. Okay, so operator type properties, right here. You have a lot of things here to change, and even the icon if you want. And now this is an HDA, and you can see it's already saved in my folder of HDAs. So this is great. Okay, let's see how many parameters we need. Oh, and by the way, because we have 3 inputs and the 4 wasn't used, I don't have the 4 input socket that I had in the packet when I did the subnetwork. I can change here the minimum inputs and the maximum inputs and the outputs, whatever you want. So now I have terrain deformer right there. And if I start typing terrain deformer, now I have it here. That's the nice thing. I put it in the sub tab of digital assets. So here is my terrain deformer, and I have another terrain deformer. This is my new digital asset. As you can see, nothing is set up yet. So now if I just create, let me just do that. And if I just hit a note here to see the output, you will see this is outputting exactly the same we have, but we cannot change anything. Okay, so let's try and change it. When you're working in a digital asset, you're not changing parameter interface, you are changing the type properties. Just keep in mind that, because if you keep changing that and save as or digital asset, you can save copy, increase minor version to do this is 1.0, so I can do 1.1, 1.2, wherever. This is not going to work if you change this parameter interface. You have to change the type properties. Okay, so now we have the type properties. Let's start doing some things here. So we can create this and say, just for starters, we can say that this is geometry, let's say ground geometry form. Let's say here bounding box for detail remesh, and this will be the character anim for the formation. Okay, so if I apply that, now here you can see it says ground geometry to deform in the input one, but because you can see it right there, right? So now anyone that can use this HDA can understand what it's doing. Great, first thing first. Okay, so let's just go to the parameters, and I have nothing here. So what can we get there? Well, exactly the same thing that we were doing. So by default, the HDAs are already without the sheet test and the nice distribution of things. So this is not working. But now I guess that I can just grab this, put this inside. This is working. So now I can just do that. And I don't want this input to do anything. Just travel from here to here so it's cleaner. And let's create a couple of folders right there. I will create a folder called remesh, maybe, and then remesh, enter. And then I will create another one called transfer. Okay, and maybe I will create another one and make it up as I go. And then the form for the mountain attributes. Come on, deform. Okay, so let's create some remesh quickly. So this remesh right here is the one that we have, and we have an attribute that goes just here. This is the default remesh, and this is the remesh using the path group. So this is great. So for the remesh, what I want is maybe I want to transform this box, but because the box is outside, I don't need the transfer to transform it because it's already outside. So it can be a box, it can be whatever you want because this group is created with the bonding object that it goes inside here, which is really the second input. So I don't really need that, but maybe I can change those numbers, right? So I can change the remesh and the really high detail remesh. So let's create here a couple of attributes. Let's do here a float and let's call it mix remesh. No, let's call it like patch remesh. So that, okay. And let's do a channel, which is a float, and let's call it path remesh, whatever. Okay, let's just create this. It's going to have to calculate everything every time. Don't worry about that. And let's put that here, 1. And this will be that. Great. And we'll just keep hitting escape because I don't want to do all the calculations. So maybe it's better to get it that. Okay, let's just copy that and create here another one called the detail remesh. That. And let's create this attribute, put this number right there as a default value. And let's just say that this will be the detail remesh. It's great. So now that I have this remesh, what I can do is I can just grab this fast remesh and put it right there. And this, where was that? Detail remesh and put it right there. When I hit apply, you will see this is green. This is already connected, so this is really fast to work with. Okay, let's just give us a little bit more space here. And what I will do is, instead of using this remesh always, I will try and create a switch. And I will create another remesh for past iterations, right? This remesh will be just like that, with the target size and nothing more. And so we can just add these to a switch. So we have two types of different remeshes. So by default, it's going to do a remesh that is so big, but it's going to be much faster to work with. And we will be able to change that to this remesh, the original one, with the adaptive using the attribute. So you have much more control there. So let me just grab this switch right here and put it like that. And let's call it remesh sample. Oh, remesh type. And because this is a label, I can do things like that. No worries. So if that's 0, this is going to use this remesh. And then I will just grab also this. Oh my God, I don't know what I did. No, I don't want that. Thank you. Okay, just want this remesh node. No, not this remesh node, this target size. Put it like that, thing. So this will be like the basic remesh size, something like that. Oh, let's put it as a name. And now here we can put it as a label, remesh size. Okay. So I will apply that. I will accept that. Not accept. I don't need to accept. Okay. So now this remesh and this basic remesh has this value, this range from 0 to 1. It's just like that. It has the value of 0.2. So let's see how long it takes. That's great, I guess. Yeah. So this is the default value. Going to be much faster. So let's just see our output. Let's look at that. And you will see that we have that working much faster because we have this remesh. That's great. So let's apply that and go back. And now we have all these. So now the remesh size, this one is going to be the remesh for everything. As you can see, this is so not nice all, but we can just do that and it's going to have much more resolution or less resolution, whatever. So this is not really easy to understand. So let's put some separators and stuff, right? Let's just put first a label and we can just move it right there. And this label is going to be called, I don't know, remesh fast, something like that, maybe. And I will put it like that. Yeah. Why? You can see this is remesh fast. Let's put a spacer or separator. I really don't know. Let's do that. Yeah, that's not what I want, but something. Come on. That's great. Then I will just duplicate this separator and also this label, and I will put that here and maybe just here. And this is not going to be remesh fast, but like something like detail remesh, stuff like that. Okay, apply it, and that's better. So now we have our basic for fast, and the remesh type is 0. When it's 1, it will be those one. So this is not really easy to see, this switch, really. So let's grab this switch, which I got it here, and let's change it. Let's change it and using a menu and using tokens and labels. So we can start the 0, 1 will be fast. So let's just type fast and fast. That's great. And this will be detail and detail. That's great. So now when I apply it, you will see that I have this. So this is 0, this is this first, and this is 1, this is the second one, and you can see it's already working, trying to do the remesh that we did, the one that is controlled with these numbers right here. This is great. We're doing a lot of things right there. So now let's just put it fast as a beginning, and let's put something like 0.3 or something like that. We will see not that much detail, but we will see something. Just apply and accept that. And now I can grab my HDA and I can save, or I can just increase a minor version. Let's increase a minor version. So it's going to be 1.1. It's the same, create. So now I have my 1.1 going there. So if I start again and create a new terrain deformer, you will see it always gets the last version that we have. That's amazing. So Now that we have that, we can try and change the transfer and change everything else pretty quickly. So what do we need for the transfer? We need the switch. This is great. And we need the attribute transfer. So this will be 0.2 by default, right? And let's just drag and drop this into the transfer. And as you can see, you can do separators and labels and do whatever you want, but I will keep it like that for now. So this will be distance threshold, and that's it. Nothing more, just apply it. So it's right there. So in the transfer, we are just playing with the distance threshold, really, because we are always transferring the color that we assigned there. And then in the deformation, we can create some things. So let's create some labels. Where do I have a label? Here, let's create label and a separator. Come on, something like that. Okay, and then I will grab them and hit D a couple of times, maybe. So this first label will be peak. Second label will be mountain. And the third label will be the mix or the form or whatever you want. Let's call it mix. Okay, so I will apply that. And if I just grab this, you can see that the form now has this. My transfer has the distance threshold, and this is peak, mountain, mix. That's great. So let's just grab the peak and just put it just right there. Let's get the mountain, and I will grab the amplitude, and I will grab the element size right there. That's great. And for the mix, I will just try and grab something like this mix attribute that we did here. So let's put it maybe at 0.5 at the beginning as a default. And let's put it right there. Not right there. I want it right there. Yeah, you can see the tree. And maybe the blur also. Yeah. So blurring iterations. Let's put it there. And maybe can just get some of the maximum points and the minimum points of the formation of the point of form. Yeah, just I'll put it that, and maybe we'll put some more labels to understand that. And at the end of everything, we will just put the subdivision there. So if we need or not subdivision on our asset. Okay, let's apply. Let's see how that looks. I think this is too much, but maybe it will work. Let's just grab these ones and hit D again, put them here, and this will be like blur effect. So we have the blurring iterations and everything, and let's just grab them again and put them right there and just call them subdivision. And because I don't like this called def, let's call it, I don't know, subdivision iteration, which is something that I'm more used to. And just because I'm changing that, so you can see now this is called subdiv iteration, but it's already connected. It's connected to this name. If I change the name and I create some name for this parameter, this name is the name that Houdini understands and that Houdini puts everywhere, and this is a label that just shows to the user. So let's put something like that, and you will see that this changed. So everything is connected and the relationship still exists. So this is great. Let's just do something like that. And we have a really great HDA that we just did. We did everything ourselves. Let's just increase the minor version again, 1.2. This is great. Okay, works. Just accept that. And let's take a look at that right now. Come on. And let's create the detailed version 1. So this is working, but maybe this amplitude is too much. Let's put it like that. This is the mountain. or the element size. You can play with that also. As you know, this will be much rougher, and we can blur these a little bit. And I guess that what happens if the point deform was doing some weird stuff really. So now we have this working much better. Maybe we don't need this subdivision iteration. It's going to be much faster without it, and maybe we can do it in render time. So now we have that. We can play a lot and we can create the really, really great stuff just playing with values like that. This is the distance from the peak, so it's going up or down. This is the distance that I want to change, distance from the threshold of the attribute that we're just doing. And as you can imagine, these can be changed. So I can grab this box, look at that, and say, no, this is too much. Let's just do something. It has to do all the remesh, so it's going to be much slower. Let me just cancel that and change that to our fast remesh type. So it's going to be much, much nicer. And oh, come on. And now I can just grab this box and put aside that, maybe even less. So I don't have this remesh at all. So now you will see with the little one that we don't have the same. As you can see, everything is live and we have more resolution here than here. So we're creating this kind of fall off just for that, just changing that. Obviously, we can change the grid and convert it to another thing. And we can play a lot with all of that. Okay, so that's that. Let me just try one last thing because we have different tests. Oh, come on. We have different tests and geometries. Let's just change this. Let's just put that as it was. And you can see right there, this is remeshing and it's doing this with the little one. Let's try and put another geometry and you can see it. It's exactly the same. And you will see that if I just disconnect this one and connect that one. Oh, sorry about that. Now this new mesh is the one that is deforming. So it doesn't really matter the input here. It can be a character, it can be a sphere, it can be whatever you want. That this HDA, your first HDA really is going to work everywhere and every time. And you can just change whatever you want. So this is maybe too much for this character. So let's put it that, and it will be creating this. So maybe the formation is too much, maybe it's too little, maybe, we can just add some subdivision here. So you can play a lot with everything you want. And as you can imagine, you can create amazing tools, and people have created amazing tools for that. So it really doesn't matter which one is the input. It will always look at them and create what we have done. So this is really great, and I think that's pretty much it. Maybe we'll do another one, but this is just a starting point for Houdini to start using it, and we'll be doing another one just for Vellum and do a lot of things, and maybe HDH and a lot of things using Vellum. So thank you for watching, and see you in the next one. Okay, just as a bonus one, maybe you were thinking, okay, but can I make it stay a little bit longer and keep the deformation? Yeah, you can do that, but you need the frame before that. You need to know that in frame 25, frame 24 was like that. So to that, we need to create a solver, and that's not really a problem. And this is not a Vellum solver, but this also can be used to create some character stuff like the blood flow or some tension map that keeps the tension and then releases it a little bit with some kind of delay. So what we can do is we can enter here, and here we have the transfer attribute really, and it's doing this. This is great. This is working. So what we can do here is just to create a solver with nothing else, just a solver, okay? And we will create something called, well, we already have the previous frame and we need the input one. So we will create that. That input one will be this attribute right here. Okay, let's see the solver. Nothing is really happening here. So don't worry about that. It's pretty normal. So let's open here and let's create something like that. And let's do an attribute run. Okay, and this attribute wrangle will have this previous frame right there, this input geometry right here. Let's put it like that so it's a little bit nicer. And what we will do is just tell we have a vector, which is the previous color that we had. And this will be a point attribute. We will see how this works, but this point attribute is just grabbing an attribute from here that we needed for points. We can do the other thing that we did, which is just something like that. OP input one, this time is the CD that we want, and that's pretty much it. So we have now an attribute right here that is the previous frame color. So we can say if our, let's create an if here and say if the X is lower than the previous color, than this value right here. Let's put this value here. We don't need the B anymore. Okay. Dot X, obviously. Then do something here. So what we need to do here, we need to say that this color is going to be previous color. It's called prev color dot X. Right? Okay. Let's see if that works. Put it back here, and as you can see, it remembers just the first frame. It just remembers the first one. So what we could do right here is to see the output and try to look at the solver. Solver is giving us some error. I don't really know what's happening here. Okay, now we are simulating everything. We need this reset button to apply. And now this is trying to remember what it was. So if it was 0, keep it the same. If it wasn't 0, keep it as the last frame. And this is for every one of those frames. So we can do this as a middle point right here. Oh, come on. Let's go. Okay, so now we can create here maybe switch, and this will be like that, this will be like that, this will be like that. Let's put it around here. That's great. And this switch, I will put it there. So let's just go here and open again my type properties, and I will create another folder called accumulation maybe, or sim, or whatever. Let's put accumulation. Okay, I don't know if that word exists really in English, but okay, let's say it works. So one thing we need is the switch to put it on or off, and 0 will be off, as we know. So let's just hit this menu and put it in off. Okay, oh, label should be off. It's nicer. And 1 will be on because 1 will be the second input right there, which is the solver itself. So that's great. Let's apply it. And let's take a look at that. We have accumulation off and on. Okay, And now, just to be safe, I will create a couple of things here. Let's just create a separator, something, and the label. Come on, here we have the separator. We can create label and say seam options, whatever. And I will just create this reset simulation button. I will put it right here. I mean, right here. Thank you. And the start frame. We don't really need substep for that. Substep is one substep in one frame, so it will be calculated one time each frame. Two substep will be two times in each frame, so 0.5 and 1, and so on and so forth. So 4 will be calculated 4 times in just one frame in each one of the frames. So now that we have that, we can just hit apply and accept that. Let's look at our output, and you can see that this is working as it was. Everything's fine, but then we can do on here, reset the simulation and start the simulation. You need to play it. You can cache the simulation right here. As you can see, this is blue, so this is caching the simulation, but now it keeps exactly as it was. Even more so, you could do something like that. This is already fine, so this is working, but just for you to know, we can just go inside this and create something here. If I put 2 slashes, you can see it's commented, so this is not working anymore. So what I'm going to do is cv.x equals clamp, and if I'm clamping that, and I create the same, but I will divide it by some silly number, like 1.05, something like that. And I will clamp it between 0 and 1. And you will see right here, if I just look at the solver and reset the simulation, you will see that now this will disappear by the time. So you could create something for this number. If this is 1, this is going to be just 1, but if I put it at 1.2, something like that, and just simulate again, I cannot simulate from here. I have to go here and reset the simulation and simulate again. You see that this is disappearing much faster. And same thing if I put some really low number here, almost 1. So it's not going to be forever, but it's going to be disappearing much, much later. So you can see this is the disappearing, but you can almost don't see it disappear. So let's say this is like a snowy place where the snow is making, it's falling and you have to make it disappear, not that fast, but something faster or whatever. So we can just go here. Oh yeah, I can just go there and reset the simulation here. And you will see now that these will disappear with time. So lots of things that you can play with, and you can do a lot of stuff there. You will see that this is catching. So I have all the simulation, or it's not really a simulation, it's just saving what happened in the previous frame. It's the way that we have in Houdini to tell him what the previous frame was. And you can see this is disappearing in front of us. So this is pretty great. And this is not at all how you do snow in Houdini. You can do snow with really complex simulations and stuff. But I will use that just as an example to show you how to do some stuff. So this is going pretty slow because you have a lot of things going on here. So what you can do, you can cache it with a cache node. And if you have some enough RAM, it will cache it and it will save it. Or you can just export wherever you need. Or I didn't show that, so let me show it. We'll be using that a lot, I guess, in the simulation part. But you can come right here and create a flipbook of that. And I will do a flipbook that goes directly to my flipbook to play. And play is like the player that Houdini has already. So let's start that, and you will see it will open another window from Houdini. Let's see if that's opening. Come on. Okay. Now it's calculating, and these can be watched at real time when it's finished. These can be saved as. This uses the FFmpeg library from Python, so you can do a lot of things with that and export it in FFmpeg, as I said, or Video for Windows in my case. So you can export it to a sequence of JPEGs or whatever you want, and you can just play it. As you can see, you can just play it real time. You will see how this is disappearing, and we have a really weird simulation right there. But just believe me, this is like the base thing to understand how to create deformators, how to deformers, how to transfer attributes from one to the other, how to create HDAs that will make our life much easier and much faster. Everything will be great, and everything will be um, faster and easier, and you can do a lot of things. So we learned some things to work with geometries, some X inside Houdini, how to create custom attributes, how to transfer them, how to paint them, how to convert them to other things and remap them, and how to use them to create some things, some character stuff like blend shades, like painted blend shades with a mask or with a mix and a mask and custom attributes for that. So I hope you like it, and that's pretty much for this one. And we will see you in the next one. Thanks. Okay, so for the assignment for this week, let's try to create an HDA just like the one we ended up with on the last lesson, but with some more things added. One of which will be trying to change the input that we have. So we had the capybara, now this is crack, another third geometry from Houdini. So let's try to not only change that input, but try to choose a part of that input. As you can see here, I'm using the hammer, just the hammer, but I can come in here and I can change it for the, I don't know, maybe the right heel. And also let's do the left heel. Let's see if I can find it. Yeah. So now you will see that the deforming thing is happening with the feet and not with the hammer. So let's add this behavior. Let's also add a distance. So to make just grow that part of the object that we're using. So it's going to affect a little bit more. So you can see I have already some animation here, but I can just change that and you will see that this has no effect and this, I'm just growing the effect. So let's try and do that. Grow that effect from the object, from the part of the object that we want. And the third one would be to change between a sculpted geometry that we already have. So let's say the artist has an input. Let's just put the hammer again. So let's just say, let's go to the last frame, that I have a sculpted that, which I have in this case. So this is a sculpted node just with something that mimics what the hammer is doing. It's not a mountain anymore, it's a sculpt. So let's try to create a switch and an input for that sculpted geometry. So we can choose if we will use a sculpted geometry or the mountain. So this will be the sculpted geometry. And as you can see here, this will be the mountain. So let's try and do that and see how it goes.